We're looking at, Jim brought up earthquakes, the recent earthquakes associated with, potentially associated with eclipse activity.
Okay.
And their proximity. Jim has been looking at this for quite a number of years. So.
Excellent.
Yeah. You want to add to that, Jim?
Oh, just just that it was a few hours ago that the eclipse happened right just north of that point in Alaska where the earthquakes are.
Yeah, I can see.
And the reason that I think that everybody misses it is because of the depth to delay time thing. Like this was very immediate, and it was also a very shallow earthquake. If you look at the pattern, the correlation between earthquakes and astronomical events, the deeper in the earth the earthquake starts, the more the delay is. I still don't know exactly what's going on, but that's why everyone misses it, because there is often more of a delay than that.
So what date was this? I've got my ephemeris in front of me. I'll just see if there's...
The eclipse was last night, really, here. It was, obviously the daytime in the other part of the Earth.
Welcome to the August 12th edition of the Electric View. I'm Neil Thompson. Today we have Robert, Dave, and Jim with our very special guest Phillip Francis, who will be showing us his full presentation that he did at the Bath Conference, but with even more detail. Our question period turned out to be quite extensive as well. Please like and subscribe below.
It was hours before these earthquakes started.
Okay.
And if you look at the map of where the peak of the eclipse was, it happened just north of that that area there.
Okay, so the actual eclipse time was 1842. So I'm just seeing if there's anything else, and it's in Leo, obviously. I'm just seeing if there's anything else. I can't see anything obvious. I was just wondering if it was picking up at another planet. But I can't see anything. Can't see anything especially. 18. Well, it was in conjunct to Pluto. That would have, if it had gone on to 19, then it'd be exactly in conjunct to Pluto, which is underground movements. That's the only thing I can really see. So, what time did it go off, this earthquake?
Well, the red ones are in the last hour, so it gives you an idea. Just I don't know, the largest one was maybe a few hours ago.
Okay. So we've actually we've gone into the following 18th. So we're going into towards the end, literally the end of by the looks of it. So yeah, almost going into Virgo, yeah, Mars was going back. I'd need to have more time to actually study that. Yeah, my head is elsewhere today, obviously, with this talk.
The one thing that's coming up is Jim, that the islands of Madagascar. Are you interested in talking about those as well?
What's happening there? What's going?
Yeah, was there anything? Did you notice anything post our last astronomical event that you were mentioning?
Not yet, but they're going to get a second wave of that pretty soon, just because of the way that Mars is in retrograde. It has nothing to do with that Mars is in retrograde, but because Mars is in retrograde, it's going to put the moon and Mars in the same sky over the same spot, and that's the bigger trigger even than eclipses. Is when the moon and Mars are in the same sky over a fault line. That's definitely a trigger, and that was the trigger for the biggest ones, like the Indonesian one and the Krakatoa volcanic eruption.
Right.
But just not on that date. It's like within a week, 1 week to 2 weeks afterwards is usually the biggest one for deeper events. Like I say, this one was like really superficial. It was a very shallow earthquake. So whatever's going on with the energy, it takes a while for it to come to the surface. And if it triggers something just below the surface, it's going to be almost immediate. If it triggers something well below the surface, it's going to take a while to erupt. And that's where like the mainstream community misses the correlation because of that time delay with depth. But the bigger ones are actually usually the deeper ones that end up being more significant.
Right. Yeah, this is a whole interesting thing that you were mentioning that we've got more study. Once again, a rabbit hole that we're looking at, but definitely curious about learning more about what's going on there. Jim was mentioning they've turned this into a bit of a penal colony in a way, and
we could visit that again. That whole thing is a mess from when the British kicked the people off the island and killed all their animals because they didn't want to move them, and then they brought in people from the Philippines to work there and didn't obey the labor laws because Filipinos weren't really U.S. citizens, and on top of all of it, they put a naval base there, and Navy whistleblowers are saying that they're piling the ships in too close to where they're worried if one ship goes from anything at all, just the whole fleet will go. But it's a place with a lot of bad juju right now.
Yeah. It's very interesting. So thanks for joining us today, Phil. It's great to have you on.
It's a pleasure. It's always nice to join fellow people and have a chat. It's always good.
Yeah. So how's the post-bath? Any exciting news for after the conference? Or
yes, indeed.
Have a get together or something.
At the end of the conference, we were talking about how we take this forwards in this country or this side of the pond generally. And me and Rob Shaw said, well, we're going to try and start a London group, a monthly meeting. We had an informal get together about a week ago, just in a pub. Just to gauge an interest. It wasn't a proper meeting. It was just people getting together and sitting around a table in a pub. And I brought different groups together who I've given talks to and I know. And I was hoping for about a dozen people as a nice core. And we ended up over the day or over the afternoon with about 15, 16 people coming and going. So we were really happy with that. So we decided to take it forward. And so yesterday, I went to see a friend of mine who owns a company called MAP, which stands for Music, Art and Print. And it's got a recording studio. It does T-shirt printing. It's generally a nice vibe about the place. And we've arranged basically to do our first talk there. And hopefully then monthly until Christmas and see how it goes. So we've got our first one booked where I'm going to give my Weber talk on the 1st of September. So we're going to see how it goes really. So yeah, we're quite excited about that.
Nice.
Very cool. So how many people participate in that?
Well, we're going to see how it goes. Hopefully, everyone who's up at our first informal chat will come along.
Okay.
So, yeah, if we get again 15 people, then I'll be quite happy. But I mean, really, the room can take up to 40. So we'll have to see, how we do, because obviously we're going to have more people to actually proper talk. We're going to push, and also Matt will be pushing for some of their people as well, because they're basically an art organisation. So this is a real, really different for them, having sort of science coming into the building. Even though I've worked with Matt since '92, so a long time. I've known him a long time on the art side.
Okay.
But this is a real divergence into the world of science. So they're quite looking forward to it as well, really. So yeah, I'll give you a report once we have our first one.
That'd be great. Yeah, it sounds exciting. It sounds like a great idea. I mean, this is the thing that we're seeing kind of happening. Is this melding, and kind of it has an activism feel to it, which gives it a lot of energy. You know?
Yeah, absolutely. Because obviously because it's an art organisation, and artists are normally rebels. So we're very much going in with that in mind. Is the fact we're science rebels. And so that's the way we're pushing it to the artistic community. So
right,
and so yeah, good fun, I think.
Yeah, very cool, very cool. So unfortunately, I wanted to sign in and get the thing started today. I'm under a crunch for a project, so I have to sign off. But please continue, and I will be there with you in spirit. But duty calls for some reason. So.
Is Neil with us?
Yes, we are. Yes, I am. Yes, we are. Yes, I am. I'm doing well. How are you doing?
Yeah, very well, thank you. So did you want me to give my talk tonight?
Well, yeah.
Absolutely. Fantastic.
That'd be great.
That's how it's happening, yeah.
Yeah, great. I'll check it on the post after Neil posts it. So, but thank you. Thanks very much for joining us, and I'll be back in the normal schedule next week. So
nice to talk to you again.
Nice to talk to you. Okay. All right. Bye-bye.
Yeah.
So. Go ahead. Talk. Robert, are you there? You're controlling the screen, I think. Are you?
Yes, I'm here. Sorry, I was muted. I'm just, help me out with whatever sites you need to show up. So I'll keep the visuals going so that people can be following what we're talking about.
Well, Phil might want to take his own.
I'll fill in for David's spot.
Yeah, no, and I think what would be best is for me to, because I've got all my pictures and video clips.
Okay, if you can do that, then that'd be great. Because then,
So for the hour, I'll just go through it as a normal talk, and if you want to make notes, write things down, because it's going to be quite involved. Going right down to the neutrino, believe it or not, for weather. And so make notes, and we can chat about it afterwards. That sound good?
Sounds great. You can take the screen whenever you want.
Right, I'm just trying to. Right, have you got my screen?
Yep.
Okay, there we go. Fantastic. Electric Earth and Weather Mechanics. This talk on the electric effects of both our Earth and its weather has been designed for those who know of the electric universe, as well as for those who are new to the subject, but have an interest in how our planet is and how it works from an electrical perspective. With the traditional mainstream understanding of how our weather operates, and because it is based from purely a mechanical view of the universally accepted standard model, mainstream weather forecasting and the understanding of its mechanics can only have heat-changing air pressure in their modelling, and so only use fluid mechanics in their multi-million-pound computers. But with all the electrical charge that is in the atmosphere, they should of course be using electromagnetic mechanics instead. So even though what is commonly believed in the standard meteorology goes completely against both common sense and the laws of physics, and which both say that an external electrical environment must definitely have an effect on something that is fundamentally made up from different charge, mainstream meteorology still chooses to ignore it at this time. But what do we mean by electrical charge? It is quite a loose and ambiguous term. Well, to start to get our heads around this, and the mechanics in general, we should first try to start to understand what makes up the material world around us, and which is made up from atoms that have different charged values. But this is easier said than done, as even this basic understanding of the atom's makeup has gone through quite a few changes over the years, and this is now happening yet again. And especially when people are now looking at it from an electrical universe perspective, and so returning to a previous understanding, and before the purely mechanical view was forced on the world for political and economic reasons. Although there has been those that suggest that an atom's makeup, both the nucleus and the surrounding electrons, are plasmoid instabilities, or variants on some sort of pure energy makeup, I personally don't go along with this pure energy model. Originally, the atom was described as having a nucleus, and which was made up of matter, with much smaller particles of matter, called electrons, circling it, and at different distances from the nucleus, and so seen just like little mini solar systems. These days, though, the electron is said to be like a shell encompassing the nucleus, rather than just tiny particles in orbit around it. But when Nikola Tesla, the brilliant electrical pioneer from the turn of the 19th century and into the 20th, was asked about the electron, he said, "There is no such thing as an electron." So from my weather point of view, and with Tesla's comment in mind, it backed up the way I was looking at the electron, and so giving the electron an atmospheric perspective, and so being layered, and which we can clearly see with the Earth's atmosphere, by the way the clouds flatten out at different atmospheric boundary layers, as well as the way the clouds at different altitudes can move in different directions. Plus, this is also what we observe with the Sapphire project, which also has atmospheric layers, but due to the higher power of input, shows them up in the frequencies of the electromagnetic spectrum which are visible to human sight. With both the Earth's atmosphere and with the Sapphire project, they have a medium which allows the layers to form. So what is the medium in the atom? As it is supposed to be just empty space between the nucleus and the electron. And thus again, this returns us to a time before Einstein's view of reality was given full rein. And so once again, returning us to electromagnetic ether, and which Einstein rejected in his model of reality, with him sending us down the purely mechanical particle collision and gravity-only route. But when we consider that the electromagnetic force is 10 to the power of 40, or 1,000 billion, 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 billion times more powerful than the Newtonian gravity, or as Einstein saw it, the bending of light by matter on a flat bit of rubber cloth, and so not even a force, it surely stands to reason that electromagnetism and electrodynamics is far more likely to have an effect on matter around us, rather than just Newtonian gravity or Einstein's dream world. So at the moment, I am seeing an atom as having a nucleus of solid matter, with electrons surrounding it in the form of charged layers, just like an atmosphere, with the innermost layer touching the surface of the nucleus and then radiating out, with the amount of electron layers an atom has changing the charge value of the atom as a whole. So my line of reasoning comes from the way the atmosphere works, both on Earth and with Sapphire, with the electrons' shells being formed by an energy input into the atom's nucleus. When there are the same amount of particles in the nucleus as electrons, the atom is said to be in a state of neutral charge. But when an atom nucleus requires more electron shells than it was in a neutral state, it becomes negatively charged. And when an atom loses electron shells from a neutral position, the atom is said to be positively charged. And so it is the amount of electron shells that alters the charge state of the atom, and so has nothing to do with the nucleus itself. It is traditionally thought that it is the movement of electrons from one atom to the next. That is what we know as electrical current. But there is even disagreement with this interpretation as to what is happening. And once again, I do not agree with the traditional way of thinking. This is because if they are atmospheric layers as I see them, then it would be the input into the nucleus that would be moving. And so moving electron layers would be a response rather than layers actually moving by themselves. So now we come to what is the input into the nucleus? And this once again takes us back to the thinking prior to Einstein and the electromagnetic ether. which was widely accepted in electrical circles at the time, and with today's understanding, is made up from neutrinos, and which are different little pieces of matter, but very separate from what makes up the atom's nucleus. So the way I see it is that the neutrinos, which starts as a neutrino 0-point energy potential, interacting with the matter in the nucleus of the atom. It charges the nucleus through electrodynamics, with it creating an electrostatic response, and so creating the electron layering. But now, and rather than keep saying the movement of the ether through the nucleus creating more or less electron shells in an atom, I will just for convenience say the movement of electrons. When there is an imbalance in two charged objects, they will attract each other. But when they are of the same charge value, whether that is positive or negative, they will repel away from each other, with this being akin to what we see with artificially created permanent magnets, with the north of a magnet attracting the south of another magnet, and the north of a magnet repelling another north of another magnet, and the south repelling another south. But with electricity, and when there is a charge differential with the same charge value, be that negative or positive, they will exchange the electrons by way of the neutrino inputs to find a balance between the two. And this is done by way of a circuit corridor. And these circuit corridors are called Birkeland currents, and which are the transmissions of electrons through open space. Because electricity and the way it operates is fractal-like, electricity acts the same way over many orders of magnitude. And so Birkeland currents can be seen at all different scales, from a static spark from a door handle to powering galaxies. Plus, I also see them as the electrical connections between atoms that make molecules, and which are traditionally known as the molecular bonds. So Birkeland currents, because they are scalable, they also connect stars within galaxies, and with smaller currents then in turn connecting the stars to their planets. So it is the Birkeland currents that connects the Earth ionosphere system to the Sun, with the interface into the Earth ionosphere system being seen as the aurora. Birkeland currents, though, are not just power dumps in one direction, but instead of us circuits, with charge running backwards and forth in a circuit, and so continually adjusting the Earth to the Sun's variable electrical output. With this basic power output from the Sun being given a boost when the Sun gives out a CME or stream of solar winds, as they add to the flow of electrons in the Birkeland current and so increase the input energy into the Earth ionosphere system. The Birkeland currents from a more powerful charged object like a star to a planet is done by carrying the electron circuit to the poles of the sphere, and this process can be seen with an earthbound experiment that was first developed by Christian Birkeland, and which the currents are named after. As with any type of plasma phenomena, and whether it can be seen by human eyesight or not, it is the current density that makes it visible or not. And if it is of a low density, then the current will not be powerful enough to be seen in the very thin sliver of the visible to human wavelengths of the electromagnetic spectrum. But as the current density goes up, they will then start to glow, and this happens as the electrons hit other matter states, and where they then pinch to a smaller size diameter, and so increasing the current density within the tighter diameter of the current.
A modern-day reproduction of an experiment that's actually over 100 years old. The Plantarella was originally designed by a Norwegian space physicist called Christian Birkeland, who in 1899 led an expedition to the top of an Arctic mountain to study the northern lights, or the aurora borealis as they're also known. Birkeland was actually the first man who really started to understand how the auroras were formed, and back in his laboratory in Oslo he built this experiment to show his ideas to the world. This particular Plantarella was designed by CNRS in France by a French scientist called Jean Lilliston. And it's a vacuum experiment. So what we have here is a vacuum chamber and a vacuum pump, which is a bit like a Hoover home. And the vacuum pump sucks up most of the air out of the chamber. Not all of the air, but most of it. So it's recreating the conditions about 100 kilometers altitude where we see the aurora. Now inside this vacuum chamber you've got a big ball here that represents the sun, and a small ball over there represents the Earth. And within this small ball, we have a really strong magnet recreating the Earth's magnetic field. The next thing we do is we put a voltage from the Sun to the Earth, and so we're drawing electrons from the Sun towards the Earth. Now this recreates a solar wind of charged particles that is always flowing away from our Sun and into outer space. Now when these solar wind, or when these charged particles come towards the Earth, they get trapped onto the Earth's magnetic field lines, and they get funneled into the northern and the southern polar regions. And when they get to the northern and southern polar regions, they collide with the gases that are there. And what they do, they excite these gases, and they actually give energy to the electrons within them. When these electrons relax, they give out a light at the characteristic frequencies, thus creating the aurora. That's basically how the aurora is created on Earth, and similar to how the aurora is created on all planets that have a magnetic field.
As is seen with a simple novelty plasma ball, and where the currents are in glow mode, the Berkeley currents are not just single filaments though, but are at least two filaments spiraling around each other, with this giving the moving charge the rigidity they need to travel through open space. But when they get to a surface, they will once again separate and contact with the surface individually. And in the case of a sphere, with an internal magnetic field, this will be at the poles, as just seen in the video clip. Even though it might be thought of as being one current coming into one pole and one going out through the other, this is not the case, and already stated, each current is a circuit within itself, with charge travelling in both directions through it. This is shown when seen in cross-section as alternating cylinders within the current, with the amount of cylinders in them depending on the strength of the current they are transporting backwards and forth, with the incoming and outgoing charge in the circuits spinning in opposite directions around each other. After the incoming electrons enter the atmosphere through the poles at the pinch regions, or the aurora, they become visible due to them pinching and so increasing their power density at these points. The electron charge is then transferred to the atmospheric ions, and it is here that they stop being Berkeley currents and become individual and separate atmospheric currents as they travel down and back up through the atmosphere to complete the overall circuit back to the Sun. As the incoming hydrogen particles enters the Earth's domain, with some electrons being funneled into the atmosphere at the poles, these electrons will need to ground, and so will leave the now positively charged ions behind, with them making up the atmospheric layer around the Earth. This then creates a system that is a bit like a capacitor, with one pole being the positive ionosphere and the other pole being the negative Earth, and with the H2O laden atmosphere between them being a dielectric component. But unlike a normal capacitor, the Earth ionosphere system has charge travelling through it in both directions rather than just one, with the down current and up currents passing close and next to each other. And it is this that gives us our weather. With the down currents being the concentrated areas of electrons moving through the atmosphere and grounding the concentration of charge into the Earth, and so making it negatively charged. With this movement downward charge known traditionally as the atmospheric lows, with them spinning their way through the overall radiation field coming back from the Earth. Because these atmospheric molecules in the down currents have naturally electrical spin, they act like a vacuum cleaner and so produce areas of low pressure within the atmosphere, with the return current lifting the H2O from the oceans as vapour, with these traditionally represented as the atmospheric highs. Yes, there are variations in strength in its overall returning field, but it must still be regarded as an overall field of radiation, rather than just being an individual area of higher pressures, as seen in the whiter areas. We have known for some time that the atmosphere contains electrical charge, and which from ground level up to the top of the atmosphere rises by about 100 volts per metre. And there are different companies and individuals who are now experimenting with harvesting these atmospheric ions and then storing that power for later use. So it is the Earth ionosphere basic circuit. The incoming charge concentrates at the auroras and then travels down through the atmosphere to ground, where it then passes through the Earth before emerging once again to travel back up through the atmosphere and back to the aurora as a returning radiation, with the returning circuit being accelerated as it is being attracted to the surrounding atmosphere, ionosphere, but once again pinching above the poles, with this process regulating the Earth to the changing electrical environment of the Sun. So the charge enters and exits the atmosphere by way of the auroras, with the downcomers naturally trying to ground along the paths of least resistance. That means going straight down from under the auroras, and in the case of the Earth, this means mainly straight down at the South Pole, and where it has free reign path down through the attractive salty waters to the Antarctic oceans and surrounding Antarctic continent to the oceans below. Whereas at the North Pole, it is a broken mix of land masses, mixed with mainly conductive freshwater ice, and so is not as attractive as with the South. So the weather we experience here on Earth is a result of the Earth adjusting to the incoming electron charge from the Sun, and which is variable in nature due to the Sun being electrically driven, with the Earth then having to adjust to these changes in the electrical field, with part of that adjusting mechanism being the H2O molecules, changing their matter states. And we can see this in action with the total cloud water filter, as the downcomers interact with the returning radiation. And we can see this especially at the South Pole. Plus, with the decline in the forming and destabilization of the solar filaments, and which in the other source of coronal mass ejections, or CMEs, it does mean that there is less charge reaching us now, and so a general cooling is taking place. Whereas the solar wind seems to be quite constant at the moment, albeit seems to be lessening now, there is definitely a trend for a declining sunspot number, and so with it a lessening of the shorting out of some of those sunspots, and which then gives us some CMEs and blasts of charged particles that beats up the circuit between the Sun and the Earth. As well as this, there's also a lessening of the Earth's magnetic field that protects us and diminishes any big hits that the Sun normally gives out. And this is also the result of the inflow of electrical charge into the Earth getting weaker. So no, the Earth's magnetic field is not generated purely from within a solid inner core, rotating in a liquid iron sheath, as speculated by the mechanical model. It is produced by external events, and so is also the consequence of the Sun's electrical output. The exact mechanism for the internal workings of the Earth and its makeup is still open to debate with different people within the electric universe community. And although not the official electric universe thinking, I go with an expanded Earth scenario, and where the Earth grew in size under extreme electrical stress in the past. This is because I simply can't accept that it is pure coincidence that all the continents at this point in history, when we were able to view such things, just happen to fit together pretty much perfectly on a much smaller scale.
We come to the Earth, which, well, grew to get here, the way it is now. Here is our world, our planet Earth, floating in space. We will be going backward in time, imperfectly, but done in a very disciplined manner. Please notice there is no subduction, no rotation of tectonic plates, no twisting, no form-fitting, no altering shapes or sizes. It would be impossible for these continental plates to fit together perfectly without this being true, and yet the upper tectonic plates fit together perfectly on a much smaller planet. Yes, there's been some erosion, landslides, blah, blah, but overall this activity is insignificant. There is a kind of conspiracy of silence among certain scientists. They know, but are not telling you, that the upper tectonic plates of Earth also join in the Pacific. Not partially, they join totally. You are asked to believe that the continents swim or drift about willy-nilly, bumping and crashing as if they were on a greased skillet. This is not true. The simple truth is apparently too upsetting to too many apple carts. We're now going forward in time to show how the actual growth of the Earth took place, imperfect as to details, but the overall is nailed. Antarctica, as you see, has become subtropical. Africa on a smaller globe moved way downward under the globe. In fact, for hundreds of millions of years, the bottom of Africa was the South Pole. South America's tail goes under and wraps around the bottom of Africa, then incredibly joins coast with Antarctica. 65 million years ago and more, these continents were joined, and marsupials like the duck-billed platypus roamed from Australia, Antarctica, and across southern South America and up into Africa. The platypus. Dinosaurs roamed all over this group on the upper tectonic plate because there were no oceans, just shallow seas. Here today, Antarctica is frozen over, and Australia and its surrounding islands are the remaining home of marsupials. Do you see how broadly the Pacific is opening compared to the Atlantic? This is exactly why the knee-jerk Pangea theory exists. The Pacific spread is too difficult to easily visualize because it's so big. The Atlantic spread is so obvious that a child would recognize it, but they are the same.
But if the Earth has expanded, then what is left inside? At the moment, I am of the opinion that the expansion has left a core floating inside a void made of plasma, with the expansion happening between the core and what is now below the crust and magma, and possibly a crystalline structure below that, with the core being held in place by the equal force acting on it from all sides, and so keeping it secure in the middle of the plasma void. This idea of a stabilized central core also means that it works with the idea of how atoms maintain their structure, with the central nucleus maintaining its place within the shell or shells of electrons. Edwin Karl has already deconstructed the atom's original makeup and reformulated it. But like all good scientific investigators, he's never stopped looking for a better and more complete model, and so just automatically believing that he's already found the answer. But his model is different from mine. After chatting to him about his model and combining his thinking into Thornhill's thinking about the electrostatic nature of the atom, and so what gravity is and where it comes from and how it operates, a more complete model was emerging in my head, and so allowing me to adjust my model of the overall mechanics. So the new atomic model that is being proposed here, and with what we know of as the charge structure of the atom being purely down to the electron, and then combining that with both Wales and Edwin's ideas, I am at the moment concluding that the atom is purely made up from what amounts to being just a neutron core, and so possibly not even having any protons. This, though, is pure conjecture on my part, as Edwin's model at the moment has no neutrons as such, but instead has them as proton-electron pairs acting as a neutron. But we will have to see where this one leads in the future. But like with the Earth's core that is also proposed, we have the nucleus being naturally in the middle and held in place by electron shell or shells, due to the forces all around it being equal on all sides and so holding it in place. In Thornhill's gravity model, the nucleus is driven to one side of the electron shell, where it will then make the atom structure into a dipole, and so making the nucleus positively charged in comparison to most of the negative shell being pushed away from it. With my model though, and with the Earth producing a radiation, the nucleus of the atom will be dragged outwards rather than inwards. But in either case, this will make them electrodynamic in nature, and so working with longitudinal waves, and so having any effect being almost instantaneously felt, and which gravity has to be, and so not being transverse waves, which only travel at the speed of light, and so is far too slow to keep any planets in orbit around a star. with the atoms in the planetary body then lining up in line with the outgoing radiation, and so lining up in series configuration, and which is exactly how permanent magnets are manufactured and so work, with the metal being shot through with a high electrical current, and which fixes the alignment of the atoms in one direction of the moving charge, and so aligning them in an electrical series configuration. But why are only certain materials magnetic? This is because of their molecular structure being able to freeze and hold atoms in an atom-aligned configuration after the charge stops flowing. So a permanent magnet has a residue of a flowing electrical field being expressed as the alignment of the atoms in one direction, south-north, 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 etc., with this series configuration then producing the magnetic flow within the metal, with the north end having all the atoms in alignment behind it, pushing the field forwards. And when it reaches the end of the magnet, the field naturally swings around to the south end of the magnet, and so creating a magnetic circuit. This magnetic field can be seen by giving a charge boost by connecting a battery to one end of the magnet and then connecting some copper wire from the north to the south to complete the circuit. So the spinning magnetic field. And this can be seen as such. With a permanent magnet and the alignment of atoms, any ferromagnetic metal such as iron, cobalt or nickel will react to the magnetic field by being drawn to that flow of magnetism, and so will attach themselves to that flowing field at the closest point to the flow. All matter will be affected by a massive flow of charge though, and when all the atoms are aligned in a dipole configuration, as with a massive object like a planet, it will pull on all objects within the field. This pull will then be enhanced when a magnet has an atmosphere, as the atmosphere will also be in that dipole configuration, with the much more dense objects being attracted more powerfully by the pull, and so making them appear heavier. When going into orbit, you suddenly reach a point where gravity suddenly stops, and you become weightless, rather than just fading out. And this is when you go past the end of the longitudinal wave, coming from the surface of the planet to its ionosphere. So the electrical return circuit from the Earth aligns all the atoms in the same direction by dragging the neutral nucleus away from the stretch electron shells in the direction of flowing charge, and so making the electron shells very close to the nucleus on one side and away from the nucleus on the opposite side, and so out and away from the mass. In my latest thinking, and with the latest model of the atom in a dipole configuration, which has one side of the electron sheath now having the neutron nucleus becoming a charged positive state in comparison, because it has hardly any of the sheath there, and so then leaving the other end of the electron shell, and which is most of it negative charge, and so creating this dipole configuration. So this atom configuration on mass creates a gravitational force, and his white is very weak, but very constant. Because the charge comes into a sphere at the poles, and much stronger at the south within the Earth, it produces two hemispheric torus electrical fields, with a line of interaction between the two fields at the equator. And this can be seen by way of the two different ocean currents from the two fields interacting with each other at the equator. But because the expanding Earth still has a central core, and because the Earth has an unbalanced configuration at the surface, most of the land masses being in the northern hemisphere, The majority of the incoming charge is attracted to the South Pole and around the Antarctic landmass and through the conductive salty waters, and which are there is a lot more of, having less landmass. Because traditional fluid mechanics is still used in modelling of the weather patterns and not electromagnetic and electrostatic mechanics, it does seem that the mainstream are completely unaware of the impact charge has on our weather, or at this time are purposely choosing to ignore it. Or they do know about it, but are not openly talking about it just yet, with this being due to them not wanting to upset any of the other advocates of the standard model in all the other sciences. So this means that instead of using the primary driver to understand what is going on with our weather, they just look at the byproduct of the moving charge, the temperature, air pressure and humidity, etc. But it doesn't matter how much one spends on supercomputers. If the model which has been input into the computers is insufficient, then it stands to reason that the output from the model will also be insufficient. And a fine example of this is the Hurricane Falls storm that hit the south of the UK in 1987.
Can't go by in Michael Fish's life that someone doesn't mention the Great Storm.
There we were at home, watching the weather, listening to Michael Fish, believing and trusting every word that he said.
You were in people's living rooms so often that they began to recognise you and put a bit of faith in your forecasts and things, I suppose. But most of the strong winds, incidentally, will be down over Spain and across into France. Michael was just so confident that everything was going to be okay. I'm sure Fish regrets even mentioning this phone call. He only mentioned it as a joke. Good afternoon to you. Earlier on today, apparently, a woman rang the BBC and said she heard that there was a hurricane on the way. Well, if you're watching, don't worry, there isn't. Rubbish! I'm shouting at the telly at the time. No, it's there. I can see it, Michael. Really, I don't have any meteorological training, but there's a big storm behind you, just on your right shoulder, mate. Well, if you're watching, don't worry, there isn't. There isn't. There isn't. Worst gales in 3 centuries sweep through Britain the next morning. Carnage, bedlam, trees uprooted, caravans flying through the sky. Power lines were down, all the telegraph poles. They came without warning in the early hours of the morning. Winds that hit 110 miles an hour and then went off the gauge.
There was so much damage caused, especially over the south of the country, that it was just absolutely horrendous.
There's flooding too in many areas, adding to the distress of thousands of people in the south of England.
15 million trees were gone. I mean, half the forestation in southern England was just gone overnight.
There was no warning. The weathermen were caught with their forecasts down. The Home Secretary has called a crisis meeting of ministers. Yes, I could see it'd be windy because of bits of leaves and things, trees and things, but it didn't dawn on me until several hours after I'd been to work that something major had happened. Why weren't we warned? Didn't the weathermen know there was such a fierce storm on its way?
I think the first 2 words most people were saying was Michael Fish, although they might have inserted another word in between those two.
This was one dramatic scene near Bournemouth as early morning drivers were taken by surprise. In a nearby Highcliffe, 90 pensioners had to be evacuated when their roof was ripped clean away. I would say anything these guys will believe, you know what I mean? These poor guys in bed without a care in the world. Wake up in the morning thinking, oh, where's those stars come from? The roof just blown off.
Michael Fish must have been cringing with embarrassment when he saw what happened the next day. But I think he was also shaking with anger because everyone was saying he got it wrong. And he was like, no, it wasn't a hurricane.
Well, for a start, the hurricane we're talking about in 87 wasn't a hurricane. You can never get hurricanes in this country. It's just simply impossible. Touch wood.
He must have just wanted to curl up and hide away forever. I would not have wanted to be Michael Fish that day, or really any other day either.
I'm looking at you, Fish, if you're watching this. And I'll find you. My dad lost his shit through you. I did get fed up at the time, and until I retired I got very fed up because I couldn't answer for it. The others were not very keen to keep bringing it up. And I shall go to my grave with it probably on my tombstone.
Even though the storm that swept through southern England was of hurricane strength, left massive amounts of destruction, deaths, and looked exactly the same as a hurricane, According to the accepted wisdom of mainstream meteorology, the reason it wasn't a hurricane was because hurricanes can only form due to heat from the tropics. And of course the UK isn't anywhere near the tropics. From an electrical perspective though, it isn't heat that intensifies weather systems but electrical charge. Whether it's down currents that pinch together, like with the UK non-hurricane events, or strengthening a tropical storm into one after even a strong solar wind stream hits our atmosphere. But it's not just the Earth that a correct understanding of weather is important for knowing when extreme events are going to take place. But is of vital importance for when we venture out into space to colonize our worlds and other worlds, both within our solar system as well as out into stellar medium. So wherever in the universe, it's the most important to properly understand the source of weather, and that means understanding the electrical nature of stars and the electrical connections between a star and its planetary family. Meanwhile, back on Earth, the reason we feel like we're being invigorated when we go out on a windy day is exactly the same as when we get invigorated when we go out in the sunshine. And this is because we are being literally charged up by electricity running through the atmosphere. It is said that when we have the right amount of the suntan, we are in glowing health, and this is due to getting just the right amount of charge from the sun directly. But to keep on the right side of a healthy glow and in the process of charging ourselves up, it is most important that we're also able to stay grounded, so that charge can run through and out of our bodies, and so making ourselves grounded part of the Earth's electrical circuits. As not completing our grounding circuit will also mean that we hold any excess charge in our bodies, with this being detrimental to our health and overall well-being. So we're walking barefoot on a beach, and especially through the surf, and which is electrically conductive salt water, this is definitely the best thing to do. But even generally, and when not necessarily near a beach, we must also take steps to remove our flip-flops and other insulating footwear in our gardens and parklands, so we're able to let the charge flow through us. Too much direct charge from the sun to our bodies, and without being able to ground that charge, and the electricity will start to build up and deteriorate the skin, and even expand it into really painful blisters. And this is because when an object takes on extra charge, it has to expand its surface area to accommodate that charge. If an object can't expand though, then it will inevitably explode, as we see with some rocky bodies, as they enter into the electric field of a planet or sun. The deteriorization of surfaces, and which includes our skin, is usually best put down to the ultraviolet part of the electromagnetic spectrum. But without going into the producer of the EM spectrum, the moving electrical charge itself. As these frequencies are going into the ionizing part of the EM spectrum, and with prolonged exposure to those shorter wavelengths of the spectrum, it will damage our skin and other surfaces, unless they can expand to accommodate the extra movement created by these frequencies. If they can't expand sufficiently, then heat will be generated in the molecules of the surfaces vibrating, or in other words, accelerating in their movement to that higher frequency. As a side note, I think it would be a really good idea to ground hospital beds in a trial, and especially for those patients who are bedbound for long periods. At the moment, the beds are normally mounted on rubber wheels for easy movement, but it does mean that because of the insulating wheels, those in the beds will not get the grounding they need to recover more quickly. So by simply using a conductive lowered bed sheet connected to an earth-strapped circuit, it will ground the person. Also, I'm thinking that this might well be the reason why bacteria and infections are getting the better of the drugs we are currently using, due to them fighting for the control over a weakened body, due to the excess and ungrounded charge it is holding. This area of research could also, of course, be extended to cancer, antibiotics and vaccines, and especially vaccines, as they quite often use both electrically conductive as well as dielectric compounds in them, and as we know, we are beings that think by way of moving charge, and generally exist because of our electrical responses to our environment through our electrically active central nervous systems. With the sun, it is quite obvious when we have just the right amount of charge, and with it making us feel a whole lot better when we're out in it. But why are we invigorated by the winds? This is because all atmospheric wind is ionic in nature and so electrically driven. And so this is why we also feel exhilarated, as it is not the actual moving air that is making us feel good, but the charge running through the atmosphere. Yes, the air is moving to a degree, but not as traditionally thought of, and in the amounts that we would normally have been led to believe. Instead, it's the electrical charge trying to ground that is moving, and it is this that we feel as the pressure of the wind. So it's an electrical pressure, not just wind pressure. If we stand in a stretch of water and we get pushed about by the wake from a passing boat, yes, the water is moving up and down and a bit forward, but it is the energy travelling through the water that is doing the pushing, and not the water itself. So the water is just a mechanical medium that is carrying the kinetic energy from the boat's movement, and which we see and feel as the waves. So yes, the water will move to a degree, being a fluid, but the pressure will be from the energy that makes them waves of motion. But with the wind in the atmosphere, it's the charge moving through the atmosphere we feel as the pressure, and so making atmospheric wind ionic in nature. The wind that flows through our atmosphere is not from a single source though, but comes from different charge reactions within the atmosphere. With a localized wind, and rather than just being from an overall downed current, as with an atmospheric low, it is produced by the release of charge that comes from the water molecules changing their matter state from vapor to liquid, and so releasing that extra charge energy into the system, and which was holding it in that higher matter state of vapor. This process can be more easily seen, though, when looked at the other way round. So if you start with solid water ice, and then add energy to it, it becomes a liquid, as the molecules have to move around faster due to the input of energy. If we then add even more energy to liquid, it will become a gas, with the molecules moving around even faster. If we then add even more energy to the gas, the atoms will be moving to such a high frequency that some of the electrons will start to break free from the nucleus, with the gas then becoming conductive plasma due to the free-flowing electrons. And so, by reversing this process, the different matter states must lose energy in order to drop to a lower matter state, and it is this that produces a localized ionic wind, as the water vapor becomes liquid or even solid, as in hail. So rain is made by energy on the water molecule being lost, with that released energy then adding to the larger electrical energy that makes up the weather system as a whole. With hail rather than rain, it is the H2O molecule going from a vapor state and turning very quickly to solid, and so there is a double release of charge wind being produced as it quickly goes from vapor through liquid and into a solid, with these events sometimes, and when very extreme, being called microbursts and rain bombs. But how can clouds hold so much water in the first place to produce microbursts and rain bombs, whether in the liquid or solid state? And of course they don't normally, as the clouds are just acting as conduits for the condensing H2O that is coming down from higher in the atmospheric layers. But once the clouds form, and so become extremely negatively charged, with lots of ionic wind now circulating inside, then that lost energy will act on the water droplets and the solid hail and reduce their weighty mass, and so make them lighter, and so be able to withstand the Earth's gravitational attraction. Then when enough charge is built up and is released into the cloud from the changing H2O molecules, as well as from the incoming charge from the ionosphere, the cloud will discharge and the rain and hail will fall, with big winds then being felt. So the process is having water vapour in the atmospheric layers, having charge removed by initially the nucleus in the atoms of the Earth pointing outwards, and then attracting the neutral water vapour above, and which is positively charged in comparison from higher atmospheric layers. Then because the clouds are negatively charged from being formed themselves, they will be repulsed by the negatively charged Earth, and so will flatten out at the boundary of the Earth contact atmospheric layer. And because the clouds are negatively charged, they will attract more water vapour from below and above, as the water vapour is positively charged in comparison. Then as the charged water vapour is drawn down and up into the clouds, they will then start to take charge from the H2O, and so turn it into rain, with the now released charge being felt as the wind, as that released charge has to also now ground. So the cloud is mainly a conduit that allows a mass of rising and descending vapour, and with enough water vapour above in the clouds will naturally grow up through the different atmospheric layers as a repeating process. and so attracts more water vapour from even higher in the atmosphere. And if there is enough water vapour above, like being under the jet stream, then this is when we get the really big weather systems forming, and which will become full of excess charge. As already stated, when charge enters the Earth, it does so at the poles, and this is because the Earth has a strong magnetic field, and which directs the input and output currents to the poles. As the concentrated charge moves down through the different layers of the atmosphere, the charge is accelerated due to them entering the Earth's electrical field. And it is this entry into the Earth at the South Pole that is the overall main driver of the ocean currents. With the down charge that enters at the North Pole, plus the negative currents that run off the land, moving the oceans in between the land masses, and especially from the equator, where the twin currents returning from the Earth mainly emerge in these localized circuits. Under the aurora borealis, in the northern hemisphere, though, we have no central landmass, but instead a combination of broken land, plus a mix of electrically conductive saltwater and frozen non-conductive ice. And so the down charge from the ionosphere is not as attractive to the planetary sphere as a whole. And so what charge is coming in here is broken up, and so gives us more disruptive weather patterns through the atmosphere. When storm clouds pass over lines of highly charged currents in the Earth, with all the nucleus of the Earth's atoms stretching outwards, they will start to attract charge in water vapour from above en masse, and so a weather system will increase in size and volume. And this is why storm systems can be seen evolving very quickly, but moving over the land really quite slowly. And this is because they are sticking to these highly charged ground currents and the atoms in the Earth. The overall mechanism generally, though, as far as bigger systems go, is for the electrical charge in the down currents to drill their way through the overall return fields. And as they do so, rub up against each other, with this giving us the lines of convergence. This isn't just a shorting of circuits between opposite charge, though, but is also the balancing of the same charge but of different potential. Because in the northern hemisphere, downcomes are trying to ground through a mix of different matter states, as well as being conductive and non-conductive, rather than straight down through the water to the ocean beds, like in the southern hemisphere, the down currents will be attracted towards the margins of the sea and the Earth, and so where the ocean shelf from the continental land masses are just below the conducting surface of the water. On the smaller scale of storms being developed along the convergence line between the charged air masses, we can get water spouts, and these locally formed Birkeland currents on the convergence line form near the margins of the Earth and the sea, and where the thin layer of the attractive salty water is just above the Earth's surface. Once formed, these electrical currents are quite often seen heading inwards and towards the land, and once there, they start to fully discharge the ground and so weaken. So this grounding happens with the smaller currents on the convergence line, as well as with the larger system as a whole, like when a hurricane, or even a UK non-hurricane event, as they develop and need to discharge their load to ground. As we know from Don Scott's work, when a dark Birkeland current forms, it has charge running both ways in alternating cylinders. And so rather than being destined to discharge like a power dump, like the emptying of a capacitor in one hit, it is a mechanism to balance the charge of the negative Earth and the mass of the negative clouds above. Depending on a charge gradient, multiple shifts can be seen within this type of event, whether on land or at sea, although it is much easier to see with the water rather than debris that is lifted from the land. Lightning, tornadoes, etc. are all broken currents, but in different discharge modes and of different charge potential, and so act as conduits for the equalization of any charge differential, positive and or negative. There are three types of plasma discharge mode. Type 1 is dark mode and is of low power density, and so can't be seen, invisible to human sight, but can be detected by way of them producing other wavelengths of the electromagnetic spectrum, like radio. Type 2 is low mode, and this is where there's an increase in power density of the discharge, and it can be seen with human sight. This is quite often the case with dust devils on Mars, as the discharge pinches at the point of contact with the Martian surface and starts to radiate invisible light. Then there is type 3, which is arc mode, and where the discharge has such a high power density that the magnetic fields produced by the electrical charge restricts the Berkeley current into being extremely tight discharge, as the cylinders in the current are squeezed together, as with a lightning strike. Only 25% of lightning strikes worldwide hit the ground, and so are cloud to cloud, and because the clouds are negatively charged, are then an equalization of negative charge within the cloud or across from one cloud to the next. Because both clouds and the Earth are negatively charged, then this is the reason why we both get downlightning as well as uplightning, as the equalization of charge can run both ways. So how do we predict when such extreme weather conditions will happen? For longer periods, we have to ask Piers Corbyn, who is the actual governor on weather predictions, long term. But for a few weeks in advance, you can watch the state of the overall weather circuit, and this is done by generally watching both the sun's electrical output in the now, but also from about 2 to 3 weeks before, and so keeping a diary is a good idea, as it takes about this amount of time at the moment for any major solar events, and which brings us the incoming charge, to go into the Earth before then coming back out as a returning circuit. So if this time period also coincides with another solar blast from a coronal hole stream or CME, then the extra charge coming in will rub up against the increase in the Earth's electrical field from the previous hit, and so will intensify the weather systems even further. So by using this method of observation of charge hits from the sun, we can also say when our weather systems will become more intense, and by taking into account the current state of solar activity at the time, say how bad they might become. So now, and with the suddenality of a lightning bolt, we're at the end of our journey into electric weather and Earth mechanics, and so now please fire away with any questions, and I will try to answer them to the best of my ability.
I like that.
Thank you.
Yeah, that was awesome.
That was really pulling it together. There's
Really?
I'll try to.
When you mentioned the charge of the clouds, there was a picture from Arizona, the only educational institution that I ever found that talks about the capacitance of the planet as well. Obviously, as you know, it's sort of a thing. Recognizing that the rings of the Van Allen belts are actually just the ring currents on the shells, which are like voltage drops. But those shells can go right into the poles. So it's like there are concentric shells to the Earth, and that goes all the way down to the Earth and likely inside of the Earth.
Right.
So it's the whole thing.
Right, and to piggyback on that, I recommend that to follow up on Bruce Laybourne's work from his speeches in 2015 and 16 from the Electric Universe conferences, because he literally was like talking about that current flowing through the Earth and talking about a return circuit, which you two should really, like I said before, should come together and you could really display the whole thing inside and out and just throw it back to the sun.
About the Arizona thing, though, the thing I noticed was the way that they actually put that there was the charges themselves in the clouds were negative, and this is weird because we don't understand what's going on here. There is talk, if you listen to Andy Hall's work, about a thermopile happening there. which does make sense. The heat could be converted to the motion of the electrons themselves, and therefore you start getting these spiraling pathways and everything. And this is occurring. That's occurring up to the next cloud layer above us. It's not occurring. You know the thunderstorms are flat bottomed. You know, like that's what I meant. They don't. There's a layer. The lowest layer of our atmosphere up to that cloud layer seems to be just. I got to thankful for whoever put this planet together, is all I'm saying, because that protects us more than anything else. If we got even thinner, like you notice when it gets dusty, when there's smoke in the air, when there's a lot of saltiness into the air, or when there is a snow, when it is literally cold as bone, those conditions make those dust devil things very common. You know what I mean? Yeah. Like that phenomenon of just like the Martian thing where they're rolling across the landscape. But the truth is, though, here's the global circuit we're talking about right here. The nature of actually putting the charge there, we note that when the sky gets charged up, negatively charged in and around a thunderstorm, the Earth gets positively charged because obviously it's not really positively charged compared to what it normally is. It's just more protons are there. It's a direct reaction. Now, are they related directly, or is one a consequence of the other? This is what I mean. So it is a brand new way of looking at things and recognizing the phenomenon of this. We'll call it the Birkeland current, or in this case, some people have called it a charged sheath vortex, which is pretty much the exact same thing when you get right down to it. But that's why you see an inner core, which is one charge. The outer core is a different charge, the sheath of the tornado. Putting all that together and then combining it with an understanding that this phenomenon has already had one failure, as you could see in 1987, as you said. He's like, no, the rules are. Yeah, I know what the rules are. Okay, but guess what's happening here? Okay, there's a lot of wind and things are getting flown out. Big Ben has the windows blown out of it, okay? There's shit going down, like that. I don't know what actually happened, but I see the devastation, and I didn't even know that event occurred. So,
it's because their definition, standard meteorology, because it's all governed by heat rather than heat being a byproduct.
Of course.
It's purely it's this terminology.
But it is an example of a falsification of theory that they didn't even recognize. And we should have recognized anyway. I mean, we can only predict a few days in advance at best. That means that we're not really seeing it. Oh, hey, look right in the middle of that picture. You see those shells I was talking about? They're right there.
Right.
But that's what the Earth has. Earth has those shells as well. And not just the rings, and those shells right in, and seeing how they are packed together and each one interrelates. But like I said, the thickness of this atmosphere we have and its relative constituency is a incredible inhibitor to the flow of electricity. We know that. We know that. Yeah, obviously, great. This is what makes microelectronics work. If we went to Mars and we didn't have everything shielded perfectly into a vacuum chamber type of thing inside that thing, and even then, we're asking for trouble because there's so much. The currents, just a bunch of dust going by, so to speak. Here, it's neutral, and we're getting some flows here and there, but they spiral out. The magnetic field winds up and dissipates. We were talking about this the other day there, Robert, with Jacob, understanding how what's causing this weird wind that is hitting the surface of the planet, or of the bottom of his jar, with the Birkeland current dissipating. Yeah, it's just because magnetic fields, when they twist up, they will hold energy for a certain period of time, and then they will dissipate. And this recognizing the ebbs and flows of this, not just in essence the heat, but also the constituency of the atmosphere, completely changes what we can predict if we can get a handle on what we're looking at with mathematical models and so forth. And we understand that plasma is notoriously unpredictable, but as you know, there are tendencies. The Earth has a tornado alley and a thunderstorm alley. They're make predictions, not maybe in a general sense, at least.
No, you can do. I mean, you can if we can get this general handle on it. I mean, obviously we're going to make massive advancements in being able to protect ourselves. So yeah, it's just getting a better understanding of what is going on. I mean, if we're going with the old model of weather, which is purely being driven by heat, then we ain't really going to get anywhere.
Robert, you mentioned a thing the other day. You asked me a question. I think it was you or Jim. I can't remember who. And it was like, what's going on with the Earth? Why is there a big swirl around the Antarctica? I just noticed, it's right on the screen here. And of course, Phil was talking about the North Pole and showing how the shape of the land mass is there. And I'm not sure I totally agree with you, Phil. Not totally. About the conductivity of the Earth. I know that most of the time the Earth is very resistant. Rocks are fairly resistant, although they do have, lava inside of them and other things moving around, charges, different telluric currents, as it's been called. And then there is the nature of the currents that flow between the barriers between. In this case, I note that right around the edge, so to speak, of Antarctica, there would be, that transition zone. So a ring current forming there would be, expected. So maybe that has something to do with it. I was just noting the landmass and noticing that Phil's work talking about the nature, though, of the physical realities of the way that the Earth works and looks, and how flow of charges are going to try to. I mean, they seek neutrality. Now, admittedly, they're never really going to get there because of the motion of the Earth and the fact that spinning creates the Faraday disk effect, and we get charges and get these Van Allen belts around the ring, so to speak, where our torus is. But we can see that this flow is somehow happening, and it's transitioning itself to the equator to make this escape, so to speak. And that's why the middle, right along the edge, the middle equator of the Earth is very turbulent. You can never see what's going to go because there's always twists and everything, because it's like the neutral boundary trying to figure itself out almost. But
yeah, well, that's why I see. There's two toruses, and they both go into the poles, and they come out together at the equator.
Yes, and just a little bit above and a little bit below. I don't know the exact number, but I think they're
that's right. It is slightly above the actual equator, because the charge, most of the charge goes into the Earth at the south. And if you go to the Nullschool, you can see that at 10 HPA, the fact that most of the charge, because of the way it's spinning, is going in at the South Pole, and whereas in the North, most of it is coming out at the North Pole.
Which gives us the polarity of the magnet which we're sitting in. There is a spiral flying from the North Pole down, trying to get to the equator, but there is a more powerful charge in the opposite direction, which overrides that other charge, and which, of course, gives us our overall compass direction. And why,
that is the compass direction is basically because most of the charge goes in at the South Pole. Can you bring up Nullschool, or should I bring it up and start?
Yeah, go ahead. Take the screen.
Yeah, that's fine. We can share. I just love talking about that. We got to be fair. We do recognize that there are currents in the Earth. We obviously recognize currents in the atmosphere. They just don't recognize the upper atmosphere as a plasma in any sense, whereas I certainly do. I know that there's charge coming in here, and there must be a bunch, and most of it's not even getting to the surface of the Earth. Most of it is flowing to the South Pole, to the equator. Exactly what we're looking at here.
Yeah, so this is now clockwise. So in the south, that is charge going in because it's going clockwise.
And of course, we can predict the magnetic current of that because of Ampere's law.
And this is also going
or
clockwise.
Magnetic flux. Sorry.
That is charge coming out. So we have the charge going in, and each one has its own circuit. So you've got to have an in and out on both sides. So you've got most of it coming here, but you've got the return circuit here in the cell.
Yes.
And that's most of it going out. You've still got some charge going in at the north. And so we've got a south-north, south-north, and that is the flow of the magnetic field.
That is correct. Well, it's not really a flow. Remember, magnetic fields have an orientation, not a flow. But yeah, I get what you mean.
Well, I still see it as, I still see it, which it's a flow of charge, which creates, and your magnet, your handheld magnet, is reacting to that flow of charge.
Well, that is true. That is true. No, I'm not trying to. It's the EET thing in me. I'm just being particular. Basically, what I'm saying is that the orientation of the compasses is correct. The flow of charge around in that big ring there probably is what is the driving force to the magnetism probably of the planet. Now, there's obviously an opposite flow here on the northern, and it's countering that, but it's not nearly in magnitude compared to that. Therefore, we have an overall orientation of all magnetic objects on the planet, and that it gives us compass, the compass direction. It's responding to the orientation, not really that's how magnets work, basically. I'm just being particular. But don't worry, I'm not trying to rip anything apart. So go ahead.
No, it's good to talk it, because obviously, this is, I'm not saying what I've said is definitive truth, but
no, I get what you mean. I totally do. I'm just, it's just a thing. And when I respond, like, they drilled it through my head, so it's like the whole thing where, like, don't do that. It's not voltage through, it's voltage across. I wanted to correct you early on. I was sitting there going, when you went, it's the power per density, and I was, and you went in, it's the power per cubic meter or per cross or something like that. And I was like amperes per cubic meter. Like I was just, it was like, but that went through my head. But I was obviously, I didn't reply in the middle of your presentation. But you get my meaning. Yeah. Little things, and they're drilled into your head, and you can't ever unsee them, I guess.
No, it doesn't mean that drilling is correct.
Well, but it has nothing to do with this. This I'm getting on exactly what you mean. I am totally understanding what you're driving at, and but please continue. I don't want to interrupt anymore.
You can see that, obviously this is going in a direction, and this is charge going in, and it hits the Earth's electrical field, and so accelerates. This is speed of the wind, and whereas. So that's charge going in, whereas at the top, obviously, it's a lot slower. And because it's not entering an electrical field, it comes out very slowly.
Well, and you can see where it's trying to, I foresee that the reason it's sort of pushed up, if you see the neutral line, I'm going to call the blue the neutral line for now, even though it's above the equator.
Yeah, that's actually charge in from the northern torus, because, you got anti-cyclone movement there, and so this band is actually charge going in. It comes in from it's still got charge coming in from the aurora. Well, so what it has to do is actually literally go around the outside of most of the charge coming out, which also goes back to the aurora, and then get squeezed into that band. This is what I was talking to Don Scott about.
Oh, yes. No, I can see I'd see what you mean. Well, I only meant that I was thinking of it as pushed up slightly, and the reason I was thinking of it pushed up is because of the fact that it has to deal with such, that would be a powerful force at the southern pole. It will have a reaction that will, of course, by virtue of it being somewhat of a magnetic, because of the current basically wrapped around that, would be magnetic, because that's a flow of charge. Obviously, it's going to have a magnetic field and so on. That would indicate that it would be pushing up slightly and obviously inhibiting some of the flow to the northern part of the planet, which I totally see that. It doesn't. These things we call planets, if we were to build a Faraday disk, they would not look like this. We would be much more efficient. This is a mess.
No, that's right. Yeah, because it's a sphere, but also because the south is so different from the north. There's hardly any continents in the south, any land mass at all. And so it's got this free reign, whereas in the north, that's where all the land mass is. And of course, the charge has to literally stay literally to the edges of the continents and the land masses, because it can't get any further, because there's all this water ice which is non-conductive, and so it's literally being pushed out here.
And it must be a pain in the butt for it. And I can see, and plus, of course, it's being inhibited by the counterflow from the South Pole. So no one said this was going to be easy. I'll tell you that. But I can see, I mean, look at it around that island, for example. Those two islands, how they're affecting current flow in a way that would indicate that there is a flow of, if I just use the right-hand rule with your thumb, okay, and you wrap your fingers around that current and consider that the magnetic flow or whatever, you know that there is a Birkeland current sort of thing on top of that, sort of somehow charge is getting through those islands. And that's significant and ignored, it seems. Obviously, it's not happening to as much to all of them. The other, looks like the Hawaiian island chain is a little bit different, though. So...
And the other thing is cyclones and tornadoes only happen in the northern hemisphere. Yeah, they have big storms down here, but these little tornadoes and these cyclones and typhoons, they all start at the equator where it joins. The two actual hemispheres, the two toruses come out of the equator, just north of it.
Right.
And it's because the charge in the north can only go in this really weird thin band. They can only start from this, because that's where the charge comes in. Most of it will then seep underneath this and go up to the north to try and discharge.
And of course, doing a lot of fun damage along the way.
Oh, absolutely. But this is why they only appear in the north, because it's basically, this is the input in the north, whereas this is the output in the south. And so they're always going to form basically here along this band, because that is the main input in the north. And so then once they actually go in there.
See, I don't know if I recognize it exactly as that. The reason I say that is because both of them are obviously, in my opinion, inputs. They're just opposite in polarity and direction.
Well, you've got to see it as a whole as well, because it's input here comes out a bit there to produce the circuit in the Birkeland current.
Certainly, yes.
Top, it's mainly out, but it still has to have an input because it's a Birkeland current, so it's still got to have both. But because this is such an easy boom to the actual interior of the planet, that this is where most of the charge will come in, and that was, as I see it, is what governs the magnetic pole. So you've got like a double process going on here, something which is happening very much at the surface, and also what's going on in the middle of the actual Earth, with a central floating core. Is the way I see it.
Well, and that is a distinct possibility. I wouldn't know if it's. I don't know what's beyond the quote unquote hollow area in the middle. I will call it. Being what we call the inner core.
Actually, but Al doesn't believe in an expanding Earth, and he certainly he impressed on me that it's fine to talk about it, but sort of say this is not electric universe theory and then expanding Earth. And I said, fine, that's okay. I don't mind saying that, but I've said I just, like I said in the presentation, I can't see how it is not expanded when it fits together so perfectly, because the animations were made literally to the reversals in the magnetic field, so it's actually built as a proper model, and the expansion goes to those reversals. So even the expansion Earth, I reckon. Obviously Neil Adams, when he made this, talks about 65 million years ago, but I can see this literally happening 20,000 years ago.
Wow, I don't think I could see it that soon, but I definitely Well, I say that because we've seen tracks of human footprints near dinosaur footprints. Oh, I have no doubt about that. No, I've actually argued the same thing as you're arguing yourself. No, the reason I don't know if I could necessarily see the amount, like, I see that there is a significant change in the environment that this planet has gone through. I definitely see it being quite ancient, but I don't know how old, and it's certainly not any estimation that I've heard begs the question: how did you possibly make that estimation, and it always boils down to isotope decay. Since we know that isotope decay can be modified, then electrically, there's almost no point in even talking about that. So, but that said, we were recently talking about some wonderful things, Robert and Jim and I and others on the show. Yeah. And one of the things that we noted, someone brought up was the moving pole. And when I saw that, obviously ideas of expansion came into mind, but it was quickly I realized how perfect along one line that was the shift was, and of course, with just looking at the what that bottom connection is, that spiral, that would have to eventually line up to, or try to line up to the magnetic field of whatever it's immersed in, being the sun's magnetic field. It's itself a dipole. It will attempt to align itself north to south over time to that thing. And I think that it probably that's what the mechanism is. However, what impressed upon me was that these objects, these monuments that we consider obviously ancient human monuments, were pointed in directions where the pole was at a different place. And you could track that. I thought that was just a wonderful thing. Now, the reason I brought it up is because it impressed upon me the true ancientness, likely, of some of these sites. I don't even know if they were built by man. Like, I mean, I'm thinking to myself, these could have been built by Neanderthals. Clearly, like that's how I'm like the magnitude of the questions I have. So, I was only saying that 20,000. But definitely we don't know, and I could imagine this whole thing happening within a few million years.
No, that was an arbitrary thing, but it's not. We're not going back 65 million years ago. We're probably going back, tens of thousands of years. I would have, it could do, but there's no way of actually proving that. But I was just sort of saying that we don't have to look at millions of years. We're maybe looking at hundreds of thousands of years.
It's totally possible. And of course, as someone who's generally not remotely into anything biblical, I always find myself arguing for that side sometimes, and I'm like, what am I doing? Because I find it impresses upon me the magnitude of how much we lost when we decided to. I mean, I think it was necessary in a way for us to get the desire to be analytical, but now that we're matured enough to recognize this and to separate, fact from fiction in many other ways, with the full understanding of the plasma universe and plasma cosmology and the electric universe and the electric earth and so forth, then we should begin to impress upon ourselves that these stories probably said something important that we've lost it over time.
We've been governed by the standard model for the last 100 years, and obviously before that, we were probably talking about these very things.
Well, Renaissance, yes, of course.
But Darwinism and the slow evolution of species.
Uniformitarianism.
Uniformitarianism. That's it. I wrote the little thing. Avid Ben Senna, I think, and some other gentleman from Scotland decided this was going to be the way it was. And we all started went, yep. But I'm just not. Well, I mean, considering the stories, I mean, it made production better, but it didn't make anything else better. The only reason it made things better is because people didn't scream, "The sky is falling, the sky is falling," and that kind of shit anymore. Like that they were like, this was sort of keeping people in rational check. It was production was good. Yay. No longer worried about these sort of things. But these things still happened. I mean, there's stories about this. The massive comet that hit your region of town in 536 there, 537. There's, the rain of rocks that rained down over Rome in 900s. Like, I mean, to see what this really means is, it's not something, it's something that we know, but we don't even talk about anymore. And that's almost a shame, because obviously, we're going to be surprised when a comet, a charged body comes in that's big enough that it doesn't get destroyed on the way down completely.
Yeah, I mean, was it a comet hit or was it a discharge?
It's a little bit of column A, a little bit of column B when you get right down to it, because the way that it affects the ionospheres, it's going to push it right in, going to push those layers right down. They're going to compress. Activity is going to happen. It's going to happen inside the Earth as well. And then as soon as it gets close enough to ground out, it's going to pop one way or the other. It has to ground out. And the amount of energy it releases is megatons and several, like with the Tunguska blast, and that's a small one. So some of these things were regionally catastrophic. So it wouldn't be like another global catastrophe, thank God. It wouldn't destroy civilization, thank God. But it totally would mess up like a continent. So, you know, we got to be, I mean, it's not something we should just take lightly, in my opinion, but, you know.
One thing I've noticed today is that's a nice little hexagon, or half a hexagon going on there. See that one?
I love those lines showing such clear differentiation.
Yeah, absolutely.
And what that means. And
well, it shows you know the power of magnetic fields and how they interact with each other. And the fact, you know, this one, which is obviously return current, that's going in the north, it's going clockwise, whereas that one is going anti-clockwise. But also you've got another north there. That's what I was talking about, the equalization of the same charge. So
and the way it induces off of each other, they're syncretic. This is why when I talk about the energy inside the Earth, if you take all the energy going on in the surface of the Earth, all the way up to the ionosphere, all of that whole thing, all of that should also be occurring inside of the Earth. The same amount of power. It's the same thing when I talk about the surface of the sun and say the surface of the sun has, you know, so much power. Well, all of that power is being fed externally. If that's so, then we should see it expressed at the heliopause. Although the heliopause is incredibly huge, over all of it, we're noticing things happening, energy happening, fluctuations. They say hydrogen is all around this area. What's going on? What they're really seeing is positive charges versus, you know, like negative charges, and there's activity out there. Now, admittedly, because of the surface of the sun compared to the surface of that, it doesn't equate to a lot of current per square meter, but it should still be there. So this sort of thing is what I look at when I see the Earth, and I see all of this activity in such beautiful, beautiful ways. You know, it's laid out nicely. You can see exactly what's going on.
No, I mean, when Nullschool first arrived on the scene, it was like, oh, thank you, because all this stuff is going in my head, but you can't visualize it. But when you see it like this, it's like, wow, you know, and of course, you know, it just makes so much sense of, you know, what you're trying to actually work out.
Can we go over to Siberia for a second? Please keep talking.
Yeah. And, yes, so, where is Siberia? Oh, Siberia, so there you go. Yeah, but, I mean, this just shows the way that the charge literally wants to stay with the water, wants to stay with the conductive earth.
I was just about to say that when I was looking at the lakes. That's what I was looking at, some of those big lakes, and I noticed that there was charge above them.
Because the charge wants to go to the water, you know, and it wants to stay to the margins of the land where the continental shelf is.
That's what it seems.
Yeah, so you know, all over the place. You know, it's all over. You know, the charge wants to go to salt water. You know, well, most of it. I mean, you do get stuff going over the land, obviously.
Oh, of course.
But most of it is literally attracted to the salt water. And that's where it wants to sort of ground.
Well, obviously, its goal is to. There is a definitely, I mean, considering the positivity of the ionosphere and the negativity of the ground overall, they're going to want to touch.
The dipole configuration is actually got the positive at the outside, and that's why the ionosphere stays away from the Earth, because even though it's negatively charged, the actual positive of the dipole atoms are actually sticking out. It's almost counterintuitive. But that was the big thing in my head, is like, how is this working? You know, because which way is it going? And I started to think, well, of course, the dipoles are being dragged, because it's a negative field coming out as a radiation. That is actually pushing, it is actually dragging the dipole nucleus to the outside, but to the outside rather than going in, which is Wales' model. Yes, so I'm thinking, that's the way it works. It's because it's literally the return circuit, which is the radiation, the overall radiation, and it's actually dragging all the dipoles literally outwards, and that's what keeps the ionosphere at a distance, because it's positive repelling positive, but it's still a negative Earth.
Oh no, just electrically there should be a positive charge below the surface of the Earth. Clearly,
well, I think it's the actual atoms of themselves in that series configuration, but literally the actual north is literally on the surface, even though it's negatively charged Earth. The actual the dipole field is actually is radiating out, and so the actual south would be literally on the inside of the Earth, and all the norths are actually on the surface in that configuration. Do you get what I mean?
Well, I do. Obviously, I can recognize, but perhaps maybe this is just simply a misunderstanding of the actual conditions, and not. For example, if electrons are going in one direction, ions are going in the other direction, and the wind would be charged, would be ions. So maybe that would give you an understanding of how things could be very duplicitous. You're not really thinking, because we normally don't think of, we think of electricity as the carrier, but that's not necessarily true.
I'm just seeing a moving electrons, which is going back to, what it's actually driving it, which is the neutrinos. But it is, we talk about sort of ions being attracted to, I'm looking purely at the electrons and the movement of the electrons, and not even really thinking about ions. I'll just see them being trapped in the ionosphere in the Van Allen belt.
Well, I just meant that if we look at the wind, for example, going in this direction, that's the electrons will be going in the exact opposite direction to that. See what I mean? That's what I mean by we're not really seeing it the way that we might not be visualizing it the way that we think that we are, because it's just. And don't get me wrong, I am no way critiquing anything here. This is obviously your idea behind things. Should be investigated if you have evidence of it, of course.
I'm just saying it the way I see it,
right.
And then I'm putting it out there for other people to come back and say yes, no, or you've got something right, you've got something wrong. That's an interesting way of looking at it, or whatever.
Of course, that's why we're here. I mean, I can't. I mean, do you think me and Jim agree? Or he's lingering in the background, but.
I'm not so scrambled to write this.
Well, that's what I mean. There's the only way we can move forward together, and and always challenge our own preconceptions or conceptions. Ask our friends if this is a good idea, and then we are learning through the collaborative nature of the whole electric universe.
That's the good thing about Electric Universe. We're not out there then arguing, we're actually coming together and discussing it up front, which is, is such a better way of actually doing it, by us all talking and discussing it and coming up with a common consensus, if you like.
We could test the theory we're looking at right here by building a Torella, putting some actual impedance objects, things with certain conductivity, be well designed, and come up with an idea what would this look like, and high-speed cameras to film things in slow motion, get an idea of what we're looking at, where the currents would try to go.
It's exactly what I'm going to do, because it's actually building a model of the Earth, and actually having the non-conductive land masses at the top, and having just the central land mass in the south, and literally building a model Earth, and then seeing what happens.
Yeah, and exactly. Because don't get me wrong, this Nullschool thing is beautiful, but at the end of the day, it's an understanding of an approximation, or an understanding of a situation based on also going through a filter that they're looking through. However, it would be really nice if we could actually see what reality brings, and that to me there's no comparison for experimentation. And the sooner that these individuals who are the people who are the ones who are preaching cosmology from the pulpits will come to terms with, the better. Because if I have to see one more, if I have to see one more model, okay, or one more artist's interpretation of a black hole, I swear I'm going to lose it.
I agree.
I had to stop looking at that stuff because a long time ago, because it's driving me crazy. Because this crap. And that's why I'm sort of saying, give us the money. Give us the money. We know, we're so far advanced in our thinking, our understanding. Give us the money. Because you can see what they're going to do is they're just going to listen to what we say and then build their models around what we say and try and shoehorn it into the standard model.
I keep talking about that. They're going to be called out for the pigs that they are if they decide to do that.
Well, to be fair, they're going to try, but let's not even get that through. Pretend that is not going to happen. However, the fact that we are documenting it across YouTube. Okay.
Fair enough.
The fact that we're doing this
about it openly,
exactly,
and it really negates their thinking and stopping them actually doing this sort of stuff.
However,
so hopefully.
I don't want to. I mean, the revolutions have occurred before, and it did not destroy. It moved power from, for example, from the church to the universities, or to the schools, because they could produce something that was of value to society. This, for example, is of value. The ability to predict the weather, to change the weather, to understand its intimate natures, and to be able to say, no, we don't want it to rain there. No, we need to change that.
Or to predict earthquakes.
Or that's a whole other ballgame, but totally along the same vein. This is the future. This is what when Star Trek talked about it, we have a weather field that prevents that sort of thing. Well, it started with things like this. And it's going to start just like Jacob Gable did with a bottle in his garage with dirt in it. Okay.
Yeah.
This is the same thing. We don't need $1 million. We don't need $1 billion. We don't need anything like that. A few nice people with a little bit of money, and just maybe even 10 grand. You could probably put everything you need. Because I would be particular on and try to make the model that you're building in a Torella and make it scientifically, well documented and well reported. Get someone in there to help you. It wouldn't take long, just to verify everything, change a few things here and there, make sure this is what happens if we use this to emulate the atmosphere. Because these are things that you try to do. It would also be nice to see what atmosphere does to a charged sphere. Will it stick to it? Because don't tell me, and no one's ever heard this problem before. Why does the Earth have an atmosphere? Why do atmospheres exist on anybody at all?
The difference is,
shouldn't they fly off into space because of the container being open?
Well, no, because not if you think in terms of charge. If you think of air pressure.
Oh, that's what I meant. Exactly.
Yeah.
And it can't be air pressure, because if it was air pressure, then all the argon would be floating right above the atmosphere and we'd all die. Because
it's actually suck out into space. If it was, gravity couldn't hold it.
Exactly.
The atmosphere would literally be sucked into space.
There must be something else that's causing this effect. Something that's not just generally charged. Not just generally. It's not gravity, but not exactly something.
Air pressure.
Well, it can't quite be that either. See, because there's all this. There's something pulling it towards the surface of the Earth.
I'm right. That's what I'm trying to follow along. It can't just be that either. It can't be air pressure, gravity.
Right.
It has to be a charge.
Well,
Visually on display right now is just, I don't know why they don't see it.
What I see.
Well, they probably do see it, but because the whole of the standard model's tied up together, and as I was saying in the presentation, that no one wants to upset anyone else, because you take one card away and the whole pack falls over. The whole house of cards comes tumbling down. So as soon as one discipline sort of says, "Hold on a sec, this is not right." This is why I'm pushing, especially for the medical side, because they are open to what we're saying, and they're behind the scenes actually listening to us very carefully. I've talked to professors and researchers, who are looking into dementia and various other things, and they are listening to what we're saying, although they can't come out openly and say it. They are very much listening to what we're saying, and going along with what they're saying. Because,
that's what I meant by, why I shouldn't think of these people as, buggers completely there, Robert, because some of them are trying to do good work and to make things happen their own way. And this is how revolutions sort of happen.
Well, I'll go with that. I mean, I meant the ones that are just ones to be snakes to get the funding.
Well, but that's, I think, the realization of the truth of the matter.
Funding, not get like the information out there,
Okay, fair enough. I have no desire to see that happen either.
There's plenty of resources, of course.
Well, I think that we were just talking about the nature of the banding, and I've noticed that obviously Jupiter comes to mind instantly. I mean, looking at the way that the South Pole even has the multiple tornadoes like the other South Pole does. Yeah. It could also.
Well, that's just the thing I'm thinking about, because obviously, the way is it the same as the Earth as other planets? When you look at Jupiter, you think, well, that's where all the current is going in. You look at Venus, and it has one pole which has that double vortex.
Yes.
So it seems to quite normal for. I mean, we can understand it on the Earth because of the formation of the land masses, but it seems to be quite natural that it wants to go into one pole and out the other pole anyway.
Well, there has to be a predominance of flow. I think that if there is a flow influenced by the magnetic field of the sun, which is obviously has a very strong magnetic field. And other bodies are inside this field and seem to align up to its neutral location, where the field, there seems to be a balance. It does seem to align with it, perhaps, or try to over time. And there seems to be a flow in one direction than the other. That also seems true. It seems to want it's going. I mean, there has to be a predominant flow if it is in a current, if the sun is immersed in a current or otherwise influenced by one. However, talking to Jim makes me realize that's not exactly what we really know about our local environment. We know that we are on what looks like a tube, but we're stuck to the side of it, and we seem to be flowing around like we're caught in a tornado ourselves. So it's hard to immediately assess just exactly how we're affected by this environment. But I bet you dollars to donuts that it affects the field, it affects the direction and polarity of our current that's flowing through it. And this doesn't change the fact that obviously, just like the sun, there is a Faraday-like effect that's going on, around the Earth and around. We've noticed the torus around Jupiter, and all those same effects. So, and we see even the attempt to make something like that, but with planets that are on their side, but still trying to make their magnetic fields align with the sun. So clearly there is, it's not just some sort of weird dipole, spinning dynamo in the middle of the planet. Clearly there's more going on than that.
There's got to be more than that, yeah.
And obviously with the idea that there are layers there outside and inside of the Earth, and we've even, I think just recently I saw a post somewhere, I don't know if it was on the electrocosmology or like universe theory or where it was, that's mentioned specifically about something about detecting a charged layer inside the Earth and in the mantle, they said.
Yeah, no, I mean, I saw that. I can't remember where that was. But yeah, it's I mean, we've got televic currents, which you know about. So, again, there's a lot of research to be done to actually track these currents down, because obviously they do move. But can we find the major currents within the Earth?
And as you said, there are medical professionals that are very interested in seeing what this has to do with health, because they're obviously. Those people who are interested in curing anything that are not necessarily, like, say, in the UK or most Western nations who want to are not, as we know, the problems of just give them pill idea is not what they want. They want to the best way to be healthier is to be healthier, like to eat healthier, to interact with your environment in a healthier way, type of thing.
One of the things I noticed at the conference, which was really good, because obviously I gave a shortened version of my talk at conference, so we all had to sort of cut in half basically. But one of the things I did say was about the grounding. And one of the things I loved is after the talk is the amount of people who took their shoes and socks off and was walking around in bare feet. And it was, really nice that people actually took that on board, including Michael. I've got a great picture of him in bare feet, and people are taking it on board because it's like, well, yeah, it makes sense. Let's ground ourselves. Let's get these, get the energy flowing. And I'd love to see that trial being done where they start insulating people in beds, giving them a ground sheet and connecting to them an earth circuit. And
well, you know how easy that would be. Those things are cheap as you could get.
Oh, yeah,
I mean, I use them all the time for.
You just got to stick them to the earth pin with a plug.
Yep.
Obviously, give them the right plug. So,
yeah, but I have one of those right there that just made for electronics, so that you are always, there's a charge, so you're always zero, so you're always grounded, and because when you're working with high electronics, you don't want to build up a charge while doing your clothes or anything, right? And that's going to cause a static shock. And even though the current going through one of those little tiny shocks is not enough to hurt anyone, it will totally mess up a FET. It will totally blast a transistor all to pieces, electrically speaking, because the boundaries between some of these things, they're just not able to take, 100,000 volts, in even though that's very small, very quick. But that's some of these static charges are that high. And, but you wouldn't think that. I just touch a doorknob, you go, ow, and that's it. Obviously that's
250,000 volts, isn't it? Static charge from the door. I mean, obviously low ampage, but I mean high voltage.
Yeah, and it's just coming off of you, so it's not really going to go through your heart or anything, so it doesn't kill you or anything, but still, you see these types of things all the time, and so just buying those, they cost like $1 a piece. You just ground people out. Changing the type of feetwear from rubber back to leather.
Because obviously, we'll be cutting them out of the equation. We know how the world works, and they love their buck.
This problem only happened since like 1950s. Before that, we had leather on our feet all the time with socks. Yeah, and socks would get moist, and you'd be a good connection to the leather, and you're walking across the ground. It might as well be in bare feet for most of it. There's no issue there. But you start changing that, and now we're wearing rubber. Yeah, that could make a difference.
I see people walking around the beach in flip-flops getting sunburned. They sort of can take the things off,
Well, yeah, and obviously there's a heat aspect to heat building up and the skin's ability to handle it. But you're right; it can only process so much of that substance, which is basically what we're talking about. Is it's a chemical reaction, but it can only be so efficient, and it's converting this charge buildup, as you said, and it powers this process. This process goes to work, but the metalin can only do so much. It will only protect you for so long, and after that, it breaks down, and you're getting sunburn, and that's the way it is. And of course, when you start looking at things that way, the same thing occurs within the brain. You have a circuit, but you're not actually shooting electrical volts when you're thinking. There's a chemical reaction that goes from receptor to, what goes across the receptor, it carries a charge across. Once it gets there, it drops the charge off, it picks up and goes back.
The chemicals obviously are charged anyway because their atoms made of separated charge. So.
Well, right, but there's chemicals in there that are mechanisms to bridge these gaps and to be very fast in doing their work, and that's why we think, and that's how nerves work and so on. And I find that to be to not see it takes effort, because obviously these things stop when you're dead, but all the chemicals are there. Why isn't it continuing? Because you're dead. Yeah. Well, why? What's why?
Well,
there you go. Why? It's all it gets right down to the heart of the matter. It's just like asking a physicist, okay, what is mass? And they break down.
books haven't been taught about charge because they just see it as matter, which is obviously down to Einstein, exchanging mass for matter.
And I'm in the exact same problem with trying to understand why they're looking at this thing. They're saying there's a bunch of hydrogen out there. Well, you're seeing positive charge. Something has to carry it. Yeah, that might. But the electrons obviously can go much faster than that. So whatever you're seeing there has to have the equal amount of this, and they don't even see that. So, and they're perfect example of the spirals that we were talking about. Obviously, luckily, they don't happen on Earth very much anymore. In the sun.
Yeah, well, one thing I think I'm looking forward to is working more with Chi. I don't know if you've seen him. Is Dr. Wong, who's a member of the cosmology group, and we've been talking for years, literally over there. And we met for the first time at our little drink get together, and it was great to actually meet Chi for the first time. And he's actually an anaesthetist, and his brain is really out there. It's really good. So I can see that we're going to be chatting a lot more in the future because, it's really something I want to pursue is the medical side. And it's good to actually have someone who's really out there and, is part of our community and, and willing to be very open about it. So, looking forward to that.
Well, in the medical... Oh, so go ahead, Robert. Sorry.
No. I was just saying good for him. I'm glad it's working out.
Well, I am too. I think that what that means is exactly what we were talking about and what we were alluding to earlier is there is a reason to do this in the medical community, a very good reason to look at what we're talking about. Geology, we're basically saying, hey, your story, that's what we're saying. When you go to a cosmologist, hey, your story, doesn't matter. It's all crap. It's all crap. It's crap.
Right.
No one's going to respond to that. To the people in the medical community, they're going, well, yeah. Because, the same thing with the people who do the weather. The weather would be another great bunch of people. Earthquake prediction, which has never been tried, another great avenue. But it's not that you're not asking to change the entire world. Most people will never notice the difference. But it would be really nice if we could recognize, with this current flow, what this means for our planet, what this means for our... if we want free energy in the future, so to speak, and I mean just harnessing from these currents. Well, there must be so much energy traveling through this. Wouldn't it be really great if we could take it right out of a weather system and store it for use by, say, I don't know, us?
Yeah.
That would be, but it's not, it doesn't seem remotely feasible now. And I'm literally talking in the future. But
not so much in the future. I mean, if you just watched, what was it, the Suspicious Observers today, where Ben was talking about the Chinese and the Italians were coming with a model to predict earthquakes. They're actually starting to work with it, and so was Bruce mentioning that he was working with some Italians. So I don't know if they're all involved somehow, but it's possible. The Italians were definitely working on earthquake prediction to the point where they actually, one of the scientists came out with a prediction, and it caused the whole debacle in the country where they made it in Italy now illegal to even predict earthquakes because of all the problems, because of liabilities and whatnot. And if it were a case, if it was an incorrect prediction and you evacuate an entire city, lose all that economy, and as opposed to actually predicting it and then just freaking everybody out, but they do avoid it, But it was an incident.
You're just it is not foolproof, and so you don't want to cause mass panic when there's no need to. But it's the old swings and roundabouts. You're trying to save people's lives and property and all the rest. But if you get it wrong, everyone goes, "Well, what's all the panic about?" It's a very, very hard.
And did we just talk about that before? It's just there's a story, and the story serves a useful purpose, and the useful purpose is all that damaging bad stuff. That happened way in the past. That's not going to ever bother you ever again. Let me reassure you that everything's great. Now go to work.
And if you get killed, it's your bad luck.
Yeah, it's nothing sinister. Don't even look at it. That's just the way it is. And that's. And don't get me wrong. There's a reason to think that way, to be part of a productive society, but to ignore, something like, if the amount of times that in places like where I'm at, the amount of times that we've had earthquakes can be measured in once in my lifetime, I think. So, other people, however, they would probably be getting these things happening several times a year where they get predictions, and some of them would turn out to be false. Yeah. Mm. And people are going to say, my economy. Would it be better if we just let it happen? And it's basically, basically money for lives is what it is.
That's the money. Right. It's moving around money and not people. It's, it's about, people's shares and bank balances and, but that's really a product of the 20th century, isn't it, really?
Well, that's what I mean. And so I think that, well, I wouldn't say a product of, obviously, way back when. It was still pretty crappy as the Industrial Revolution took off. But disease, cholera, not even knowing how to clean a city. But yet, here we are talking about the ancients again. They knew how to do it, and why didn't they totally, have these problems? It just makes you think. Yeah, well, what can you do, right? But I hope that, we start listening, because this is where reality, where we actually feel. Anyone can tell you how's the weather is what we all say to each other, because at the end of the day, we can't control it and we can't do anything about it, and no one has a clue what's going on, generally speaking.
Well, that's fine.
The only thing that really knew before the modern age of the television and weather predicting was what? The Farmer's Almanac, which was basically what old people would tell you is going to happen. Well, they tend to get it right a lot of times. So, absolutely. Because what? Oh, we're old and we watched the clouds and stuff, and we sat here with, that's what they were doing. And they're basically telling you this is what's going to go down. Now, how can they know what's going to go down? Because they're making generalizations on things that they recognize in cycles and systems. Taking that and taking that and being more exacting with understanding what they don't understand what they were seeing, but they at least were being honest about it. This whole taking numbers and saying one thing then another, and then forcing it into rules, get into your situation that happened in 1987, or the situation that happened here with our ice storm that we didn't see coming. Why did these things happen? We have no idea. We guessed wrong, now.
The models aren't good enough.
Well, and we should know why.
That's the trouble with fluid mechanics I said to this satire, I said to Michael, it's like, why are you using fluid mechanics? I said, you've got a charged environment and an atom's made of charge. I said, you can see with Nullschool that fluid mechanics doesn't work because stuff doesn't flow into each other. It quite often tries to avoid each other. I was really surprised that they're still using fluid mechanics, and of course that's why they didn't see the tungsten tip vaporizing. It didn't melt; it vaporized. It's because they shorted out across the atmospheric layers. There's so much that's got even in our communities. People are still governed by past thinking. It's just
Well, I think that's the. Well, I think they were, trying to do MDH theory and stuff, but there is a bit of the trying to basically understand some of the, with fluid mechanics, getting the, things like permittivity and permeability of the fluid and stuff like that. But at the end of the day, though, it is reacting with itself, and it induces off itself, and it filaments. All of these things are things that don't happen in fluids. They only happen in plasmas. They only happen in, and plasma, as soon as you go above just a few kilometers off the surface of the Earth, there is a lot of ions up there compared to just the nice dense air down here. And so it will start responding to electrical forces. And
exactly. That's what I was saying about the contact layer. The contact layer with the Earth is this. See, I haven't worked it out yet, but it is so important. It's why clouds never, reach down, or they shouldn't reach down to the Earth unless obviously there's manipulation going on. Because that first contact layer with the Earth, which is basically the electron around the hydrogen. That one shell around the one nucleus, one particle in the nucleus. It's something I've been really sort of thinking about of why that happens, and why does suddenly hydrogen is such a volatile gas which will explode, whereas the next one, helium, won't. Because you suddenly got you've got the contact layer being shielded by another layer. And and it's the contact layer, whether it's with the Earth or with an atom, seems to be so important. But I haven't got my head around it yet as to exactly why. I'm still thinking about that.
Oh, and totally understand. I mean, I was just sitting here wondering. I was wondering about what would, for example, how would someone ask a question on one of the forums, I'm not sure where, and I had this big detailed answer. I think it was me and you, I'm not sure, but I just wrote it last night, and it was basically saying what would happen if in the ancient times the Earth moved environments. What happened if one of those shells inside of the Earth was no longer had the ability to be inside the Earth anymore? It was literally pushed out, and it was sort of like, conversely, if the electrical pressures on the Earth from all sides hit such a point where it pushed a layer like the cloud layer into the Earth, that layer of charge, and basically the overall charge of the Earth is now higher. What would that have effect on materials? What would it have on gravity? All that kind of thing. And because obviously that's never happened in any way that we know, but what would happen? And, if you collapse the layer down to that, you'd have obviously a massive devastation towards the planet. I mean, it would be highly charged, high amperage for a few minutes anyway. But, I think of things like that where we're not even there yet to understand fully what we're looking at. Because just like we're looking at right now, this is generally what we know inside the Earth. We don't know much.
We're working as we go along, and, I mean, it's obviously very exciting for us because, we've got some sort of handle on it, but there's so far to go to really understand the mechanisms going on.
Well, at least if it wasn't for those people who put us on the right path in the first place, and now here we are sort of...
Yeah. Oh, absolutely. I mean, we're just following on from what's gone before. Oh, absolutely. As well said originally, we're standing on the shoulders of giants, and this keeps going back and keeps going back. It was just obviously all the way back to Tesla and Faraday and the rest. Obviously, it was halted because of political reasons and the economics of the times and pushing the Einstein agenda. But and we're just picking up the baton again and carrying on running with it and seeing where it goes.
I wondered about that, because I mean, don't get me wrong. There's been talk of conspiracies and everything else around that time, but there was definitely a push by people. I don't know. See, I tend to think of these things as innocent until proven guilty, but it just, why were they pushing on the stage? Why was the Catholic Church involved? What's going on here? I found that to be very disconcerting.
Why was Einstein as the only scientist in history to get a ticker tape parade down, through New York? They were really pushing him and trying to put the electrical people, very much onto the back foot and into the back of people's consciousnesses.
Well, I don't know if they was trying to suppress the electrical thing as much as they wanted something that would confirm their own beliefs and make them relevant again or something. Usually it's not to punish something else. They just don't want to hear conflicting views. They want to go with their view that would lead them towards money or towards fame or whatever. I'm just thinking.
I got a nice attitude, Neil, but
yeah, maybe I'm wrong. Maybe I'm just naive. Maybe I'm just naive.
I'm a lot more cool.
Fair enough.
That's my North London humour, I think, coming out. I'll try and say it's that. But
well, it's the truth of it. We don't know, and you're right. It is extremely odd, and there's. Why was Fermi invited to see the first nuclear bomb go off, but wasn't allowed to view the crater? what, like, just,
Really? I didn't know that.
Well, it's just weird, these little things. And I only mentioned because of Einstein's theories led to this theory, right? So,
yeah.
And of course, that makes you wonder the nature of nuclear fusion in the first place and all that wonderful stuff. So,
it'd be great if Edwin were here.
Yes. Well, I don't want to go into it too much because he's not here. But besides, he didn't get a chance to defend against your unfounded and hurtful accusations that you made against him.
I've actually warned him that I was thinking along those lines and he didn't come back to me.
Oh, well, it's the same thing. I was blown away by Edwin just telling me how, conventional science told me how atoms work, which I was still working off this old model from, 1940s that is taught in electrical textbooks. And, but, the actual truth of the matter was different. And so on and so on. When we're dealing with, when you're dealing with what are the nature of the atoms and how does magnetism arise, all that type of thing. The things that we really don't know exactly. I mean, I thought that the spiraling of the electron was creating this magnetic field and that they were sort of pushing along in a thing, but then I learned this is not exactly correct. So.
Well, I'll still go back to, I'm going back to neutrino because, I was thinking, well, if it is working the way I'm saying, then there's got to be an energy input. And I thought, well, the only thing left is the neutrino. And, there's certainly a lot of what Tesla was thinking about and the fact he didn't think the electron existed. I'm thinking, well, then it's got to be a charge reaction of some sort, which is electrodynamic. And I thought, well, the only thing left is the neutrino. And so I started reading it, and there's so much, again, speculation, and the fact that other people have said about the neutrino and electron being the same, and I'm thinking, so there are other people thinking along these lines, but obviously no one has got any, sort of direct proof or but there is certainly a load of people thinking along those lines and do sort of go back to what Tesla was thinking, or what he said is there's no such thing as an electron. So,
well, and that's quite possible. There's no reason for me to think. I mean, me and Edwin were just talking about this the other day on a show once. I'm not sure when, but I said something about that is the electron just a reaction to the fact that there is a proton. So, like, they're always the same amount of charge because they are only come into existence because of these holes and dents in the nucleus themselves based on his model, for example.
Yeah, I feel really guilty about chucking his model away because he spent so much time and energy building it.
Well, you didn't chuck it away. We're here thinking, right? So.
Well, I've chucked it away in my model.
Well, yes, but we're gonna look at your model. We're gonna look at his model. We're gonna look at every model and see what we can figure out what's really going on because all we can know for sure is that we probably took a wrong turn about 1930, and it's not helping. It's not getting any better. So we're losing our predictive accuracy completely. So
in fact, we can all sort of come up with these models. I mean, hopefully one of us, will get there, and then we'll just all go forward with it.
Well, I mean, the general is true. I mean, the general we're all with. Basically, that charged particles have a role to play in the nature of the universe. That's really all it means. That's really all we're saying. And now the question is how, and that's and we're coming to terms with that. I mean, it was people like imagine 10 years ago we weren't even talking about the circuitry of the Earth. We were talking about just getting our handle on the last 10 years of trying to understand the circuitry of the sun, just accepting that was happening. Now we realize, hey, it's very similar to the way the Earth works in its thermosphere and blah, blah, blah. It's like the corona, yada, yada, and you're trying to understand. And then you're like, wait, but there's a lot less pressure here. Oh, the voltage shift, blah, 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 blah. So you start seeing where this is really coming into the front and what's really happening. And this is just not, imagine what another 10 years will have.
Well, this is what I put up on the electrocosmology site where we're talking about the rocket that went off today, finally got off into the sun. And I said, well, it's out of date before they even launched the thing. Because they're trying to find out stuff that we've been talking about for years with Sapphire and what we talk about on programs like this on your program. It's it's going to take 7 years to get there. Imagine how far advanced we're going to be in 7 years.
Yeah, and half the stuff we have. This is a perfect example of what I was talking about. Look at it. Look at it. Just very simple, laying out the way that a tube works, and just putting that towards looking at the way the sun works, and then looking at the Earth and all the same features, and how does it interact. That is really all it is. We're just taking something we already know something about and extrapolating it to something to include something that we weren't really thinking of in that way.
Yeah. Yeah, I mean, because I...
There you are, buddy. What are you?
Oh, blimey. Oh, blimey. You found one of my pits. Oh, God. I haven't seen that for a while.
Who is that guy?
I look like a doctor.
I know, eh? You pull that off very well.
Yeah, that was years ago. I've done that with Susan. Oh, yeah.
Well, and this is what it's all about.
Just had to put something up there, you know.
Oh, yeah. You don't worry about that, Robert. You put whatever you want up, whatever hits your fancy. Well, I mean, within reason.
Right.
That was really interesting to have Philip with all those naked women there, so in the background. Oh.
Well, I come from the world of advertising photography, so I'm quite used to beautiful naked women.
Okay. Well, I was being joking, but there you go. Lucky you. So.
Well, it wasn't past. I'm talking
Rock
about not lately, unfortunately.
Oh well, us people get too obsessed with our nerddom here, trying to figure out the universe instead, because we think that. Right. Is that a legacy thing, or is that I don't know what that is. Making a difference thing? Who knows?
Yeah, well,
I think it's a good thing.
Yeah, no, it's good that we're all exploring this, and no, I don't work in advertising anymore, so even though I'm just like an advertising exec in that picture, that's what that picture was for. Just like an advertising exec.
No, you pull it off well. I can see why you went into that field, because it was. Well, I still remember the time you scared the crap out of me in the lobby of the hotel once. So you were like, "No, I talk like this," and you went, rah, 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 and I was like, "Oh Jesus!" I really pissed him. Oh, he's acting. Oh, thank God.
That's when I was doing the cop.
Yeah, the cop thing. Yeah. Oh, it was good. It was good. But you're because you're around so many new ideas, all these new people, you're out of your element, and then he's like, "I'm going to show you my acting right now, right here." And I was like, "Dude, I've had 3 drinks. You just scared the piss out of me." So, but
luckily you know I was acting.
No, of course. Oh, geez, no, I as much as the electric universe can attract a let's just say. An open-minded crowd. I've never seen such a bunch of people who have a passion. It's been my delight to be a part of that. I mean, just that on 2016, and then obviously the Bath conference that you just went to, and obviously my experience in 2017. Hopefully,
2017 was awesome.
It was. I felt a palpable sense of. This is happening. Like everyone was smiling. They were motivated. I think there's.
We just couldn't dance. No one could do the electric slide at the dinner dance.
Oh my God, no!
That was a horror show.
But don't worry about that. They had fun.
We'll get it next year.
But what they did, what they managed to pull together just in 2017, I've noticed that it's a sort of like there's a tendency to be nervously embarrassed or worrying about what other people will think. And
don't get me wrong, they had fun doing it. Yeah.
No, I just meant in the conspiracy realm, there's always that thought because the United States is a very potent area for the idea that the CIA is watching you or whatever, like that kind of thing.
Right.
And it doesn't mean that, they don't watch things. I'm not pretending that they don't, but there was a sort of a sense of nervousness about your ideas, about sending them forth, and a little bit of nervous apprehension. How will this be received? And since the first time I went in 2015 till 2017, the 3 I went to, I saw a distinct and just amazing improvement in that realm where people were just so open. They were laughing all the time. That was caught beautifully by our friend there, Andrew Fitz, who did a little film there about after the 2017. I think you're in it, Robert. You were talking to me at the time, actually.
Oh, nice.
Yeah, you can go look it up, actually, if you want.
Yeah, send me the link.
Andrew. No, you can type it into Google. Andrew Fitz. Before the banquet or something. He also has one of us all getting our picture taken. He took a video of that too. So yeah, you'll probably love it if you haven't seen it already. But anyway,
no,
yeah, you might as well catch a look at yourself there. So, but it's sort of like people are coming out of the woodwork with their, and I won't want to say crazy ideas, but to see how concerned they were about all these little tiny minutiae. When I watch people like Jacob Gable or yourself just go out there and do it, just do it, just doing it, just showing, just getting it done. And I don't care what you think,
No, that's not, yes, it's that not giving a shit attitude, which is what you have to do, really.
I mean, look at Galileo. Galileo was to the point where he's like, no, I'm going to stand on principle or I'm not going to stand at all. And he goes, we're going to burn you to ash. So, that type of thing. Bruno Brudaleschi or whatever his name is there, or the other people, Kepler, like he was like, I'm not getting any funding for this. I'm going to use a bucket and I'm going to use a stick and I'm going to figure out orbits and you can't stop me. And then of course you have, thank God for Newton, who I don't know how managed to basically put some numbers to things to the point where people were like, all right, fine. I'm not sure exactly how he did it, but they didn't hang him. So, Yeah,
it's like Copernicus. He had it worked out, but he released his all his stuff when he was on the deathbed anyway. He kept it to his...
He was smart. I love Copernicus. He was like, I have this great idea. Here, it's all in this book. You take it. You run with that. What are you going to do? I'm going to die. No, I'm just going to be dead now so they can't kill me later. Bye.
That's it. That's the way to do it. But it was then, obviously,
And then that just slows down the progress of this type of revolution. And we're to the point now that in the last 50 years, we're no longer waiting. The internet is expanding faster than these intellectual institutions can change, and we're no longer listening to them. And I don't mean, and it's thanks to people like Hannes Alfian and Peratt there. Did you find it? Did you find it there, Robert?
Oh.
Yes.
Put it up there. I want to see it. But yeah,
what?
We're gonna have.
What up?
That one with you in the video. I thought. Sorry.
Sorry.
I thought you were looking for that.
Right. Google search or YouTube search.
So it's type in Planet Amnesia. Or here, I'll find it. Here, let me find it for you. You just play Eileen. I'll find it for you, and I'll link it to you there. All right. Okay. Now. So that I don't have to keep on wasting breath.
She's going to be on our next show.
Yes, I was going to mention that. Yes, she is definitely going to be on our Tuesday show there. So we can't wait to see and expand upon what we were just talking about in the medical community. And obviously, she does a lot of presentations on this front. But while I'm looking for that, Robert or Jim, do you have any questions for the man? Because I am obviously having a great conversation, but I'm just hogging air. So I want to hear your points of view because I can't be the only one questioning this poor man.
One thing I'm wondering is why Edwin's model wouldn't work with that idea of like electrons as shells or...
Yeah, I agree with Jim on that one.
See, like if you use all his Edwin's model, but you could get rid of in his model the only two key pieces is either you have to have these electrons or orbiting a nucleus.
With Edmund model, it relies on the neutrons being an electron proton pair. But if the electron doesn't exist according to Tesla, then I don't know how the model can be adjusted to to that, because I like the thing that impressed me when I first met Edwin Edo first. So we talked beforehand anyway, sent emails to each other. The first time we met was in 16 at Phoenix, face to face, and I just loved the way he had all the little ball bearings. And this again come back to the fact that, well, if they work so well in a geometric shapes and they held together, then why do we need a neutron and a proton? I mean, can't we just have one or the other, because it works so well with these little ball bearings? And then
we really don't need a neutron atom.
Well, I'm saying you don't need a proton, because it's the electron that changes the charge of the atom. We don't need a proton. I don't see.
Well, this is the thing. In all
you mean
honesty,
an electron or a proton?
Sorry,
Philip. You don't need an electron, or you don't need a proton?
Well, no, the electron is a charged reaction, but you don't need a proton. You just need a neutron, a neutral particle, and it's the neutrino acting with that which creates the electron sheath. That's the way I see it.
Well, I suppose, it's actually not unlike an idea, or one of the ideas for the what the ionosphere represented in the conventional model, I think. But this is the thing: we really don't know. I am 100% blown away by what I saw through Edwin in relationship to what I had, but at the same time, if we don't, what is reality in this, on that scale, is the only thing I can be sure of is that the whole quantum idea with these different whatevers of quarks or something just probably should stop. It's bothering me greatly. I'm not sure what else, but
well, that's what I just see. Like CERN making atom debris. And you get something spinning off in one direction, they call it something. It spins another bit of debris, spins off in another direction, is something else.
I got it right there. Link for you, Robert.
Oh, where what?
Right in the chat thing for the thing. Planet Amnesia is Andrew Fitz, and he basically talks about the psychological impact of the Velikovskian events in mankind's memory. That evidence alone should never be ignored, because of the fact that, well, let's just be fair. It is the evidence that we have that these catastrophes were within mankind's memory. There is a definite, no one can deny that we are somewhat of a tortured species. I don't think. At least we pass on these stories. I mean, how many stories do we have of things getting just killed? Like it was. And I mean, it must have been very impactful upon us, I'm sure.
Yeah, and I'm sure it is. It's buried in our subconscious very heavily, and that's even to the fact we like horror movies. We get excited by such things.
Well, yes, I mean, and of course, what is media but not catering to the exact same, the doomsday anxiety type of thing that they were talking about, and obviously gets translated into fighting aliens or whatever. And the stories are very similar. The hero and the damsel in distress type of thing. The monster.
Spiders in the past. Why have we got this massive fear of spiders that people have? Which is totally irrational. These tiny little things. Yet it really affects people. It makes them freeze and run away. And these little tiny insects. And so you just think, well, how big were spiders in the past? And when there were big things around, where do these irrational fears come from? They must come from somewhere.
When I hear that about the spider thing, I always think of the little hint that was given by the South Park guys there, and they said the Roman Catholic Church is guided by the giant spider. We shall ask the giant spider. And then I saw the giant spider that was on the ground at whatchamacallit there in the Nazca lines, the giant spider there. Yeah. And then I saw those sheaths that I was talking about around Jupiter. Imagine if they, just like they did in the Sapphire thing, just began to glow. You get all those layers all glowed up, and how it would look like a spider with really long legs leading out into space. Hey, that's there's me, and that's Heather. I think you're right in front of me there, Robert.
That's Heather. I think I was talking to you at that moment.
There's Buddy's shoulder, I think.
Yeah.
We were all hanging around. Oh, I laugh way too much. I laugh way too much.
That's right, and
Yes, exactly. I get scared the crap out of me. Think he's going to finish the job when I go visit him in England. But
I'm saving it all up for the visit.
Yeah, just warming me up. But I think that this is the feeling that I felt. Like he really captured that feeling. How we were all just a tizzy with all the excitement of what this means and who we're seeing, and there was an openness that was just so friendly, and it wasn't. I'm not saying it wasn't there, but there was a formality that seemed to be there before. Like they had to try to impress the academics or whatever. And then it was like, and now it's like, no. We've hit critical ground. We don't care anymore. We're letting loose. We're going to just talk about this.
It's also because I suppose in the early days it was purely scientists, if you like.
That's what I meant. Yeah.
Whereas obviously there's now people like us who got involved, and
we have no threat. There's no threat against us. I'm not going to lose my tenure. I'm not going to lose my job. None of this. No one's going to bring anything down on me.
Yeah, that's right.
My boss will not care one iota about me talking about science on the internet. I mean, it's not like I'm saying anything crazy. You might think it's weird, but at the end of the day, I'm not sitting here preaching it to anyone and saying, you must believe. How dare you not believe? I'm not doing anything like that. No one's doing anything like that. We're exploring intellectually something that needs to be explored, that speaks to us. That's all.
Yes, like the model I presented is I don't know if it's right. It's just the way my thought processes were working, and one thing leads into the other. But
Bill,
right, fine. If it's not right, then fine. It's just exploring, thought processes and sticking it out there.
That's the last last film of Bill right there.
Oh yeah, right, okay.
Yeah, sad.
Well,
people leave us.
Yeah, that's what I mean. Andy's the young up-and-comer, and he's almost 60.
Well, I'm 61.
Well, there you go. You see what I mean? Like, me and Edwin, we're the young pups, and Robert here, all in their 40s.
You're going to be left when I'm gone.
Well, that's what don't say it like that. But it's just it's the nature of life, obviously, but there is a intellectual responsibility that I think we've hit critical ground on, and I'm worried only that I don't want it to turn into I don't want it to become some sort of weird cult or religion or something like that. Like I don't like that feeling. Yeah, see how bad we dance.
Oh my God! What's all that about?
This is white intellectuals dancing. See how good they are?
The electric slide.
They're terrible in every way in dancing. Look, you see, Dave's like, I'm getting the heck out of here.
They run out of time with each other. They're out of time with themselves.
But hey, they're having
had a great
fun.
Time doing it. That's all that counts.
It looks great fun.
And
we didn't do any dancing in Bath. No, that's for sure. I mean, we were a lot more chilled, I think, in Bath. I mean, we had it was great fun and lovely and brilliant.
Well, that's what I meant. You took it somewhere else, and I know that Adrian and other people are into some UFO stuff. And I'm obviously not incredibly into it, because
Well, I still build my UFO. I still want funding for that, because I've actually, I've talked it over with Edo, and I've come up with a design, and I've got perfectly in my mind what needs to be done. Even without turning at 90 degrees at thousands of miles an hour, and be perfectly safe on the inside by simply changing your own mass to zero with charge. Then there's no inertia, so there's no reason why you can't instantly accelerate or do massive turns.
That has not escaped me. We were talking about this as well. The possibility that obviously within the electrical nature of reality and, say, a very high-powered spinning disk or ring, you could possibly create a situation where the matter inside of this vehicle is relatively neutral in the electrical sense, and if you can counter what's going on with the that would basically be countering gravity if Wall's model is correct. So yeah,
it will repel from the Earth anyway. You know, you just got to make it highly negatively charged, and it will repel from the Earth and you defeat gravity straight away.
There I am wandering around.
You know, so you know, we've got a basic model, and you know, and you know how we construct it, and in fact we make it out of Tupperware.
There I am holding up the sign with the old man.
Yeah, in the back there, I see. Yeah. No,
this is really, I haven't seen this before. It's really good to see all this.
This is the 2017 one. Yeah, this is what.
No, that's right. Yeah, obviously I didn't get to that. But yeah, no.
But yeah, but I was thinking about something that'd be really easy there, my friend. The situation, which is a drone, and the control systems for drones already exist. So, making something with 4 of these saucers on either corner, and then making it work, might be possible, and a lot cheaper than trying to build a control system yourself or something. Because all you're really doing is controlling a DC current into one of 4 areas, and that's what powers the rotors. So you just replace those. And I was thinking about this exact problem: how to achieve something as simple as possible, without costing any money, or
Well, what we need is, you know, I mean, for just, you know, a scrap of what they give to other people, you know, we could build this stuff really quite simply. You know, we just.
Well, that's what I mean. If we thought about it,
you think about Sapphire. I think the bill up for Sapphire and then is up to 5 million, which is like peanuts. You can be compared to something like CERN, which does nothing apart from smash up atoms, and that's like 100 billion or something, whatever its silly price tag is. You know, it's ludicrous. You know, and.
Ed's dressed like Ben Gedlow's dressed like a Canadian in his red and black plaid.
Flannel.
Yeah. Flannel. That's it. Flannel. Anyway, I'm sorry. I'm just looking at that there. Go ahead, Phil. I'm sorry, but I think you're absolutely right in what you're saying. That so.
Yeah. No. Give us the money.
Give us the money.
Yeah, just give us the money. Simple as that. You know, it's quite. You know,
well, I didn't plan on this being a pitch for money, but if anyone's listening, you can make checks out to me. I'll make up this whole Patreon campaign. We'll get it all taken together anytime you need. But in reality, though,
does it mean I have to go to Canada, or can you come over here?
Actually, I think that we're going to. Well, the next one's going to be in Utah, but I'm positive that if there's another one in the UK and this employment pans out, I should be well able to afford that. But the most important thing, though, is that there are people who deserve to be heard and deserve their credit to be out there, and they're just not getting the voice, and they're drowned out because the only avenues. And I think that this is what it was. I think it explains a lot about the nature of the Thunderbolts, I shouldn't say the Thunderbolts exactly, because it's not just them, but the nature of the Electric Universe to always try to go the intellectual route, because they are intellectuals. That's what they have scientific reasoning. But once the internet happened, and it really, I mean, after 2006, it has really taken off. And I bet you by the 2025, we're not even going to recognize it anymore. But that's what is happening. That's where things are happening. The people who wrote the theories 100 years ago. Like literally, the proof of Einstein's theory of relativity will happen, May 1st, 1919. And that was the observation of the sun by Eddington, where he said, look, it's deviated. He's right. We win. That's one observation, buddy.
And I've only observed it only happens at the plasma lens, so that whole theory is like half right.
Could be refraction, exactly.
Diffraction.
Yeah, it's completely wrong. Because all the stars either side didn't move. It was only the ones going through the atmosphere, so it's simple diffraction.
Which it happens on the Earth, and we know that when we see the sun rise, the sun has not risen yet.
It's bullshit.
And this makes and for good reason, we should call that stuff into question. And of course, I mean, the first falsification that they saw of the conventional model was the announcement of dark matter by saying, these things don't have enough mass. Our numbers are off. What should we do? Let's add mass. Got it.
Yeah.
That was their answer. Like, not why.
Okay.
Let's just do that.
Make some shit up.
Well, but that's not science. And it so bothers me greatly that people bothers all, thank you. But there's a certain amount of not listening anymore.
It's become too big to fail. That's the thing, because it means everyone being re-educated and being sacked, and it's like and students wanting their money back after they've lent 40 grand to get a degree. It's fine if you only need the paper; then it don't really matter. But if you want to go into the sciences and you realise you spent 5 years learning bad guesswork and you spent 40 grand doing it, then they're going to want the money back and compensation, surely. Well, I would.
Actually, it will only extrapolate the longer they do this. It's different when they came to the forefront. When Hannes Alfvén told them in 1970, don't listen to me, I was totally friggin' wrong. But if he went to a little bit further, he corrected himself, and that he tried so hard for 16 years, eventually in 86, he released a paper saying, this is how galaxies work. Stop using my old work, you dumb idiots. And then he died in about 10 years later. Now, in that time, in his lifetime, other people, for example, Casey, who came up with the the continental drift idea, died before it became popular. So let's give a generation. Okay, so one generation goes by. That's 25 years. Let's do that since he warned them. Well, we're already past that because it's been 48 years now since he warned them. Okay, let's go a bit further then. Did they learn at 86? Nope. Have they learned now? Because they're not letting the information out. If they release it to the public, as everyone could, digest it at their own terms. If you release the information on pulsars that are glitching on their own terms, if you released the fingers of God problem on your own terms, the idiosyncrasies with geology, but instead they just take these idiosyncrasies, call them some sort of object at a place or whatever, bury it, never to be seen again, like elongated skulls or something. They just throw it away and say, nope, doesn't fit.
Well, I heard you on one of your programs talking about Lloyd Pye and the Starchild stuff, did I?
Yeah.
I knew Lloyd. And because I was listening to it on YouTube, I thought, I wish I was in this discussion because I knew Lloyd. And
wow,
it was,
I couldn't.
Yeah,
I'm glad. He inspired me a bit there. I was a little blown away. I've heard some rumors about the stuff he was talking about, and I've heard some alternate things that are very similar to what he's talking about. But it was nice to see someone looking at the problem just simply objectively and not dismissing people who wrote or who were trackers, people who could study a print and know if it's real or not. Like, this is not rocket science. These people have been doing it for literally thousands of years. So to say it's not reality, like they faked things, they couldn't recognize a faked one versus a real one or something.
Yeah.
Like, come on, bud.
Yeah, I probably don't want to talk about this, or I shouldn't do, but
we obviously we're having a good time, and I'm enjoying it. So why not give it a little bit more?
Well, it's quite sad the fact that when the FOXP2 gene was the fragments found and from the DNA testing, and he was like as soon as he released that to the world, he was dead within 6 months, and it was tragic. But I used to talk to him about American football, and Because
You honestly think then, in just what your statement, before you go into the whole football thing, I need to ask, are you then saying that is it just suspicious to you, or is there some sort of that idea that this was a real thing? Because don't get me wrong, the worst things happen to good people. Look at Michael Steinbacher, but he wasn't going to change the world. What was you saying?
Absolutely, yeah, but it was a bad coincidence, should we say? A very, very bad coincidence. The fact that when the FOXP2, which is a cascading gene, I don't know if you know much about genetics.
I don't.
But okay, well, the FOXP2 gene is what's known as the cascading gene, and loads of other genes come off of that, and it has to be exceptionally stable. There's like no deviations in any humans. It's like if there's one deviation in this particular gene, then the fetus won't be able to talk if it gets born. I mean, because it's such a major early cascading gene. And like the Starchild skulls had something like 56 different variations to a human FOXP2 gene, and it was such a significant finding that it's just like a really bad coincidence that Lloyd suddenly got cancer and was dead within 6 months. It was, really quite sad.
Well, we'd have a different prime minister now if that didn't happen to one of the guys. So yeah, I know what you mean.
Yeah, so and of course he was such a driving force behind it, and the skull is still locked away in a safe deposit box, as far as I know.
I saw some of the things he found, little pieces. It was hard like enamel, like a tooth.
That's right. Yeah,
it had little pieces of red metal in it, I think.
Yeah, well, yeah, that's it. Well, they were filaments. We still don't know what the filaments are, but basically, it was twice as thin as human bone, but twice as hard, and it had it's got no other similarities to any other bone on Earth. It is completely different. Because originally, the early testing was showing that there's probably and a hybrid, and that's what the track we were going down. But as the more sophisticated and further testing were done, and more fragments were recovered, this turned out to be totally alien. It's totally alien to anything else on Earth. And then the FOXP2 gene was recovered, and and it all grounded to a halt unfortunately with Lloyd's death, which was very tragic, especially for his family.
Obviously, yeah.